agenda today. I'm going to wait. Okay, now we're official. All right, ladies and gentlemen, we have a very full agenda today, and we're going to be joined shortly, immediately, by the chairman. And okay, Kevin, let's go. But let's take care of a couple of housekeeping things before the chairman arrives. First of all, we're going to be, because the chairman is going to be with us for the next couple of hours, which in the history of the TAC is an unprecedented investment by the chairman of the FCC in the workings of this group, which we should take as a compliment to your efforts and as an indication of his support for what you're doing. But because he's going to be able to be with us for the first couple of hours of this session, we're going to structure it a little differently than before, than you're used to. We're going to ask each of the working group heads to make their presentation in 15 minutes or less, and we will be running those presentations without discussion so that the chairman can hear the kinds of issues that you all have been identifying. And then he will leave, and we will spend the last half of the meeting then going back to each working group's work product and having a discussion amongst the whole TAC about each of the status reports along the way. And I guess I probably should comment then in terms of the progress that you all have made thus far. I mean, you are clearly living up to the high threshold that was set by the last TAC in terms of being a hands-on working group. I mean, the number of volunteer hours, the excellent work that you all are doing is evident in the kinds of things that we're looking at today. And the complexity of the issues that we're dealing with are evidence in the work product that we're dealing with today as well, because we haven't got any answers. We got lots of issues being teed up. As I say, it's a work in progress. We have to continue to refine those issues, both inside the working groups and inside this body itself, so that we can meet our goal of providing deliverable action recommendations to the Commission. And I think that, and I think the chairman will probably reference this, but last year's TAC had some very specific recommendations that the Commission has taken on themselves, and that the President of the United States has actually done something about, that started around this table with the recommendations that you all have made. And so what we're going to be doing today is continuing the work through the process to deliver a set, presumably some at the next meeting, others in subsequent meetings, of recommendations that we all can agree upon, and that an important component of today's activity is to make sure that everybody around the table has an opportunity to provide input into the processes and the intellectual activities being done by each of the working groups, so that we don't have just siloed activities, but we have the opportunity to have cross-fertilization amongst all the minds around this table on all the topics. While we're waiting for the chairman, I would be remiss if, again, we didn't call out the staff of the FCC, who, as you know, are doing so much of the background legwork to be supportive of your activities. So I want to particularly call out Dan Kirshner, Henning Schultz-Rennie, Julie Knapp, Michael Ha, Chris Helsner, our own indefatigable Walter Johnson, our official, what are you called? You're the
designated federal officer.
Our designated hitter.
I can arrest you.
and lastly, but not to be forgotten, Greg Intochia. And these folks, as you know, essentially, with the exception of Walter, a new staff team working with TAC this year, and we're grateful for all their stuff. Between your meetings, I'm vamping here, guys, while we're waiting for the chairman. Between meetings, and so last summer,
You have a new book coming out?
Last.
Yes.
Bob, I apologize. My fault. Who else did I leave out? Who else did I? Ahmed. I offended Ahmed. I'm sorry. Chris is gone. Chris is gone. But what we do between the meetings that you all are having in your working groups, we then meet here as a staff to coordinate those activities and to make sure that even though there are not conclusions coming out of the working groups yet, that the commission, as it considers various topics, is aware of and sensitive to the kinds of issues that you're addressing and you're raising in your process. Let me go on and just make a couple of observations about the chairman's visit today. We should not be expecting him to opine or engage in the kinds of issues that are going to be being raised. He is, of course, the chairman, and he can do whatever he wants if he decides to engage. But as he has described it to us, he wants to take this time because he asked us, you will recall, to come up with ideas for the commission of things that would stimulate innovation, investment, and thus new jobs. And he wants to hear the development of those ideas, less of getting into the nitty-gritty of their specific implementation at this point in time, but to be able to see what we think the shape of the land is. And as we continue to wait for the chairman, let me just step forward and say one of the things that he may talk about today is a task that was handed to us when he spoke to the CTIA convention in May. We're close. Elvis is approaching the building. And so I'll let him tell you that piece of information about what he is passing off on to us. Is he in the zip code? Or?
He'll be down in a minute.
He's
on his way.
You can't say LATA anymore, can you? Okay. But the topic is the upcoming what was has been described shorthand as the broadband or the band plan forum, and which I now understand has been concisely and cogently titled the spectrum and devices in a multi-band world, driving investment and innovation. It's going to be a large report just in order to have room to get the title on the spine. But here's what he said at CTIA. He said, should we update our thinking to accommodate new capabilities available in LTE Advanced, like supplemental downlink and channel aggregation? I'm asking our Technology Advisory Council, whose members include several CTOs sitting in this room, to convene a forum on the future of band plans to inform the incentive auctions and other upcoming auctions. I hope you'll lend your strongest engineers to this effort and in general to the effort to maximize the recovery of spectrum from incentive auctions. So, as you've heard, incentive auctions in that description are part of it. I hope he's going to tell us some more about this when he gets down here, Julie. Okay. But I think we're talking about things that are beyond that. Yes, indeed, incentive auctions are included in this, but this is about broader spectrum issues, broader device issues, and he's asking us to help in this forum paint a picture as to what the spectrum future may look like as it is being defined by new technologies and new devices. Is that a fair description, Julie?
Yeah. Thanks, Tom. I think as part of the effort on multi-band devices, which we're going to talk about a little bit later today, where we've got the challenge of designing equipment for operating in multiple bands, the focus that, just as the chairman said in his remarks, is in this particular effort to be looking at band plans and the implications. We've been doing things historically one way, looking at voice services. As we go forward with the advances in technology and the shifts to data, should we be thinking about band plans generally a bit differently than we have in the past? So that's what the plan is for the workshop, I think.
And that'll be on July 16.
Right.
Here in the room. Mr. Chairman, we're just in the process of stealing some of your thunder. Welcome, Mr. Chairman.
You giveth and taketh away. And
thunder. So I've been sitting here vamping. These people are tired of listening to me talk. And over to you, boss.
Well, thank you. Do I need a mic? Should I have a mic?
Yeah.
Hi, everyone. So I'm thrilled to be here. I'm going to just talk for a couple of minutes, but then mostly I'm going to listen. And I understand that the game plan for the meeting was presentations from the working group heads and some discussion. And I promised last time very happily that I wanted to, hey Dale, make sure that I actually stayed. You all put real time into this, and I appreciate the work that you're doing. And I think what we've worked out is that I'm going to stay for a couple of hours.
We're going to make the presentations so that you can see the breadth of what everybody is working on and the issues that they're discussing. And we'll spend about roughly 15 minutes on each working group. You'll get an idea of everything that's going on there. And then whatever your schedule is, you go off and do your other stuff, and we will dive into discussing some of the recommendations amongst the group.
Terrific. Well, that's perfect. And so a few things. First of all, thank you again to Tom for putting your time and effort into this. I appreciate it very much. To all the working group heads who are working hard, and to all the members who've contributed, thank you. I just got back from a trip overseas. Literally, I got back yesterday, and so my body has no idea what time it is. But many of you have had a chance to spend time with people from other countries, and spending time with people from other countries really confirms how much exciting is going on in the American marketplace when it comes to information and communications technology. And it's really across the board. And so by focusing on mobile for a minute, I don't want to exclude other exciting things that are happening here. But you spend a little bit of time overseas and you see the ways in which the U.S. has now regained global leadership in mobile. And, it wasn't that long ago if you traveled to South Korea or Japan, you'd say, wow, they're doing all this incredibly cool stuff on their mobile devices. That's not happening in the U.S. Why are we behind? Or if you went to Europe, they'd be texting like crazy 5 years ago and, being creative about the mobile platform. And, why isn't that happening in the U.S.? It's a different world now, as you know. Japan and South Korea now, the mobile platform that they're using is American. It's iOS, it's Android, it's Windows. And I recently saw some numbers on this, which are they just knock your socks off. The percentage of mobile devices globally that have American-made operating systems in the last 4 years has gone from 5% to 65%. That's amazing. And when you talk to people around the world also about what's happening here on mobile infrastructure, it's amazing. The U.S. is going to be the first country in the world to scale at 4G. And the rest of the world knows it. And that's exciting. And so when I go and spend time with my counterparts in other countries and meet with people from the private sector in other countries, more and more the question I'm getting is, how is the U.S. doing this? So that's rewarding. Of course, it doesn't mean that we don't have some very real challenges ahead of us as a country to keep these engines of innovation and investment going. And in fact, what TAC has been focused on is exactly that, because you all know this as well as anyone. And I see Mark here, and I know Mark in his way has been leading up an effort at PCAST that's been very complementary to the work that's happening here. And it's just excellent work that together with what TAC is doing is going to make a very big difference in the future of our innovation economy and what we can do. So let me just very briefly review a couple of the things that this group has done over the last year to remind you that it's having a real impact. And for those of you who were here at the first meeting we had together, you'll remember that one of the things that I said, and I said this to Tom when I asked him to take on this leadership role, was I said I wasn't interested in setting up another debating society. And you were all way too busy for that, and it wasn't worth the candle for anyone. But that I really wanted this group, with the background of the people who are involved in this group, to help advance concrete things that we could put in place that would advance, as I said, our innovation economy. That I wanted you to think about long and medium-term issues, but I also wanted you to think about nearer-term issues where we can get things done. And I wanted the nearer-term things that we did to relate to our medium and long-term goals. And that's exactly what TAC has done since its formation, and you all really should be proud of the contribution that you're having. And let me just list a few examples, and I don't intend this to be exhaustive. One of the areas that TAC focused on starting very early was barriers to broadband deployment, relevant to both wired and wireless, because as everyone here knows, even mobile connectivity. Well, most of that is wired anyway, right, Dale? What's the percentage for the life of let's call it a mobile call? How much of it is spent in wires? Someone knows, but it's a lot, right? It's 80%.
It's a lot. We'll stipulate to the number a lot.
And so TAC focused on this early and recognized that we need to do more as a country to tackle barriers to broadband deployment, both wired and wireless. And just, I guess, 2 weeks ago, the President and the White House announced two very important actions that came directly out of recommendations that TAC made. It announced a new policy to ease deployment of infrastructure on federal property, lands and building, and I think TAC had made a specific recommendation that there was a big area of opportunity. TAC suggested that the FCC or I urge this to be done, and it has now happened. And the second thing that happened, which is something that TAC also weighed in on in a very helpful way, was this concept called dig once. Right, this basic idea that if somewhere in the country we're digging up a road, let's lay fiber at the same time. And so the other thing the president did 2 weeks ago was announce that dig once was now the policy of the United States, and he's instructed the Transportation Department and the other relevant agencies to make it happen. And in these two areas, these fit the criteria of near-term action items that we could do that will have medium and long-term positive influence on our innovation economy. But those were the only things that, thanks to the work of TAC, we've seen real progress on. TAC has been very focused on the challenges that come out of this new mobile spectrum world that we live in. These are very significant challenges, as you know. They are, generally speaking, the kind of challenges that you want to have, right? Most of our mobile challenges come from too much demand, which is a much better challenge to have than too little demand. But it does put real stress on the system. And this is something that I think from the very first session that TAC got together, you identified as an area that you wanted to make a positive difference on. And you pointed us to two things that we have moved forward on. One was small cells. And you said very early, small cells have to be part of our thinking about mobile infrastructure going forward. And you really helped us gear up activity at the FCC on small cells. I did a major speech about this, I guess 2 months or so ago at CTIA. There's a tremendous amount of very concrete planning going on now at the FCC on small cells, and some of that is related to the second specific thing that you said to us in this area, which was look at 3550 megahertz as an area of opportunity. And you said, given small cells, that may be even a particularly large area of opportunity. And in fact, I announced in the same speech that we would launch a proceeding here on 3550. I don't remember exactly what I said, but soon, by the end of the year. But that's another concrete thing that comes out of what you've proposed. I'll tell you also that on the trip that I just had, I've started discussions with my counterparts in other countries on thinking about 3550 as a globally harmonized band. And there really are opportunities around the world because while the spectrum has been issued in some countries, it's being used in ways that when I talk to my counterparts overseas, they're very open to the idea of thinking along the lines that we are. And so the impact that you may have might not only be with respect to U.S. spectrum policy, and not that would be great, but also in contributing to getting the benefits of scale economics when it comes to 3550. So that's very exciting. I see Mark here, and TAC is not the only group that has been looking at this. PCAST has been looking at some of these issues too. But one of the things I'm proud of is that we've had good discussion among the experts on TAC, on PCAST, because we're all trying to accomplish the same thing. Another area, the future of PSTN. That's something that early on you focused us on and said, look, there are issues here that are coming up as we see the trends with PSTN. And without spending too much time about it, one of the things that I would do is refer you to a speech that Sharon Gillette, our wireline bureau chief, gave within the last month on this topic. And I think when you look at that and you see the questions that she's asking, the agenda that she's laying out for the commission in this area, a lot of it is based on the kind of thinking and work that TAC has done. And so I just want to pause here for a minute because I I want you all to know how significant it is that you've been able to come together, organize yourselves, make concrete recommendations, and see this kind of action. I couldn't be more pleased because, action is what we need to keep our innovation economy going. Let me touch on some things that I know you're continuing to work on that I'm anxious to see the product of the work. I think I just walked in as Tom was announcing a workshop the TAC will host on the future of band plans. This is a big deal where the input is going to be very important and it's very timely. Band planning is one of the fundamental activities of the FCC. And as we all know, the world has changed very significantly since when the FCC first started doing spectrum band plans. Probably no change is more significant than the one from voice to data. And so the next band planning work that we do, it's hard to imagine that the same assumptions that informed the first band planning work that the FCC did should apply. There's some very important band planning activities coming up. We received authority from Congress to move forward on incentive auctions. And we've already started our work on that, and pretty soon we'll launch a commission proceeding to continue to move forward and implement that law. Well, our hope, obviously, is that we recover a significant amount of spectrum in the 600 megahertz band. And one of the things the commission will have to do is do a band plan for 600 megahertz. This is a big deal. I can tell you also from my conversations over the last few days, the world is very interested in what we decide to do for 600 megahertz because they continue to recognize that the U.S. has been a leader in spectrum policy, but also because they recognize the benefits of scale economics from their perspective as well. And so we have a chance in the 600 megahertz proceeding to do something that has these characteristics of being right for the U.S. in terms of meeting the opportunities of mobile broadband in the new era, and also doing it in a way that informs what the rest of the world does, which will also be good for the U.S. There are obviously other band planning issues that we're currently wrestling with, that we'll be wrestling with in the period ahead. So this workshop is important, and getting the considered views of TAC on the future of band planning is something I'm very much looking forward to. I know that you've been working and you'll continue to work on receiver performance issues. This is another area, you can put this in the earlier category or this one, where the work that you've done is having a tangible effect at the Commission. I hope Julie has a chance a little bit later to speak, but Julie Knapp's agenda and testing agenda for the year ahead is based in part on ideas that TAC has been putting forward with respect to receiver performance, and Julie's working on some specific things that I know he'll discuss with TAC. And there are so many other areas, but I think I'm going to wind this down. Wireless security. I know that there's very interesting work going on spectrum policy and on devices in a multiband world. I think I may hear a little bit on that from one of the working groups. So again, I would just would thank you all, challenge you again to just keep doing what you're doing, which is work on these hard issues that are about our innovation economy, about creating opportunity, innovation-driven job creation for the future, making sure that for the medium and long term we're on the right path at the FCC, but also that we're doing the things right now that we need to do to stay on this path. So again, thank you to all, and now I'm looking forward to listening.
Thank you, Mr. Chairman. Let me swipe this back. The simple fact is that it was you who gave us this task, you who redirected the kind of TAC that you wanted as opposed to what might have existed in the past, and we hope that we're at least meeting your goals in part, and we're grateful to you for making the investment you have. Now, let's get down to business. As the chairman mentioned, last year's efforts on the transition from PSTN teed up a whole set of issues that we're now dealing with in this year's TAC, and we put it into we organized it into two working groups. In a fit of creativity, they were named Group A and Group B.
I'd like to thank Dr. Seuss, actually.
I'd like to thank Dr. Seuss gets credit for that, but being in the kind of competitive, the competitive nature of the people sitting around this table, immediately one of those groups, as you'll see when we throw up the slides here, began referring to themselves as the A team. And so we have a presentation now from the A team on what they have come up with thus far.
I hope you've done. I hope you have an A team and a one team.
You know, that's just why you're in that job. You know, Nomi and Russ have been the leaders of this exercise. Which one of you is going to grab the floor? Russ. I'm looking at Nomi. I thought you were pointing to Russ. Okay.
Actually, before you start, I wanted to do something that I forgot, which is to thank the FCC staff who've been working with all of you on this effort. I'm not going to go through all the names, but it takes a lot of work on the staff side to help make it. Walter's sitting here, Julie's here, Daniel Kirshner's here. I know I'm going to forget people, so I apologize. But I want you to know that this has been a virtuous cycle. When I asked staff at the beginning to work for this new advisory committee, their mouths were saying yes and their heads were saying leave us alone. And but that's not what I see now. The staff is really enthused by the interactions that they've had with TAC, and so I want to thank all of you for that. But I really want to thank the whole team of people at the FCC who've given their time to trying to make this project succeed.
Here. Nomi.
One.
The clicker.
Okay, we only have one of these in the entire commission, and I've been obligated again to state no throwing.
Notice you didn't allow Tom to have
Yeah.
Thanks, I'll remember that one.
Very good.
Right. So I guess I would want to start by introducing our team, and I know I think we're going to try to keep this to 15 minutes. So I'm going to, instead of reading everybody's name, I do want to just point out that there are a couple of people besides, in addition to the TAC members that you can see on the slide, that also helped, and I just would want to point them out. And many of them are here in this room. Chris Murray of Earthlink, Trace Hollyfield of Bright House, Doug Jones of Verizon, and John Barnhill of GenBan also contributed significantly to our group's efforts. So I want to thank them as well, and of course the TAC staff who've helped us with our group, from Daniel, Henning, and Walter, have been tremendously helpful. So one of the first things that our group spent time on was figuring out what we were initially tasked to do, which was to focus on identifying and evaluating issues that arise out of the shift in voice service usage patterns. That's what we were tasked to do, and you probably remember the questions that we were posed in those four areas on the left about copper retirement, PSTN users, interconnection, and database. And we pretty quickly started to see conflict and overlap with PSTN Group B, and so we began to discuss whether we should merge the groups or move things around. And so this is actually a very good slide that Brian Daly made that describes the result of what we decided would be the objectives of the two groups. And because it is Brian's slide, I'm going to let him describe it more specifically. But I would just note that what we're going to discuss today are the three items on the upper right: copper retirement, interconnection, and database transition. So that's what our group is currently focused on. And this is a great slide, and I'll let Brian kind of describe some of the whys of how we ended up with where we did. And so actually I'm going to pass now, and Russ, I'll just handle the clicker. You can tell me, because since
throw it. Go long.
Go long, Cody. So We've actually had a lot of discussion in our group about copper retirement. These are the questions that were posed to us. I'm going to let Russ talk about the copper retirement first.
Okay. Thank you, Nomi. So I want to talk a little bit about copper retirement. We had several questions posed to us from the FCC. And one of the things we'd like to do, our working group that we were on last year, Nomi was a part of that as well, addressed what was called sort of the sunset of the PSTN. So we spent a great deal of time on some of the copper assets that were out there, what could be done with it, and the transition. So we want to reference the work, a lot of the work that was done in 2011. We actually held a couple of public workshops thanks to the FCC as well. And a lot of those questions were answered. So moving on to the next slide, though, where we get past the questions to some of the sort of answers or recommendations. And we really feel that the statement copper retirement is probably a misnomer. We'd like to look at that as either copper replacement or transition, because we do feel that copper today is obviously used as a broadband media. And I just want to point out, just like any other media that delivers services or broadband, everything has its, we'll just call them physical characteristics or limitations, if you want to look at it that way, whether it's fiber, whether it's wireless, Wi-Fi, hybrid fiber coax, or copper. So, when we looked at this, we felt it's another infrastructure that can be used and is used today for both broadband and for telephone services. There are many services out there that require copper today, but what we found and saw both from last year's results and this year when we looked into this matter was there's a transition underway in the marketplace. And at this point in time, we didn't see a need to sort of push that. We felt that there's a pretty good momentum already taking place on some of those, whether it's burglar alarms, security, even some of the disability type services that are out there. So that seems to be on track. Also, technology advances. If you look at copper 10 years ago, if we would have had this discussion, many people in the room would say, yeah, copper is limited to maybe 6 megabits downstream. Today, people are getting 100 megabits out of copper. Now, I want to make a caveat statement there, and I don't want to spend too much time on this single slide, but all copper is not created equal. And as an electrical engineer, going back to my days of circuit theory, copper is nothing more than a very complex, or not complex, simplistic RLC network, which basically means it's a resistive, inductive, capacitive network. You have gauge changes, you've got bridge tap, which means you've got copper feeding two areas, which is split. All these things create problems when you try to put different advanced services on it. But copper can be cleaned up. The real issue comes down to, is the economic cost to do that viable, or to replace it with a new technology as broadband speeds? And one of the things that came up too was, what's the cost to move services? There's not a single cost, because these things are distance sensitive, whether it's aerial, buried, however you want to, however the plants, physical plants put in the infrastructure out in the field. And so with that, I think our group recommends that we kind of put at least the copper questions we have right now to bed. We think we've addressed those. And so we're going to focus, at least our viewpoint, and we're looking for guidance from the TAC, but we're going to focus on interconnect moving forward and some of the issues around database transitions. Thanks.
Okay. Tom, should we move on to interconnect unless there's discussion
we'll
about
have
copper?
The discussion when we come back. This is the read-in for the chairman.
Okay. So, Marvin, do you want me to pass you the clicker or want me to cover it? I'll just, okay. Okay.
So we had a series of questions on interconnection listed here, basically recognizing that interconnection means more than just connecting IP packets, but you've got to interconnect at layer 2, you've got to interconnect at the application layer, SIP, or other control protocol. And we proceeded by trying to develop a matrix of technical issues that would need to be worked out. We have a draft of that. It's we're not going to focus on it today in detail, but we're going to talk a little bit about some of the issues we identified. Next slide. So the key point is that interconnection does not just mean IP to IP interconnection. We've been doing that for 20 years. ISPs know how to interconnect, and peering transit, paid peering, whatever. The problem is that you're trying to interconnect for the purpose of an application. Now, the primary application is voice, but we shouldn't limit our attention to that because going forward, the same application control protocols are going to be used for video, for text, for SMS, and so forth. So it's talking about voice interconnection as a proxy for a larger space of interconnection. And there are a lot of groups working on that. The Association for Telecommunication Industry Standards, the GSM Association, the Canadian regulators, Cable Labs, 3GPP Partnership. And there is a fair amount of voice over IP interconnection happening today, an increasing amount. But there's a great variety of different ways that this is being done. In the appendix to these slides, we show some scenarios of the different ways that carriers are choosing to interconnect for the exchange of voice over IP or other real-time session traffic. This is going to be transformational in the sense that voice over IP is not today economically accounted for in a distance-sensitive way, and yet a lot of the rules that we have for circuit switch involve rate centers, LADAs, inter-exchange fees, and so forth that don't make a lot of sense for voice over IP interconnection. Some of those issues are already the subject of FCC initiatives. A follow-on further notice of proposed rulemaking that grew out of the Universal Service Intercarrier Compensation Order is already accepting comments on this topic. But there are certainly plenty of market forces pressing towards this interconnection today. In the next slide, we list some of the differences between PSTN interconnection and voice over IP interconnection that we've identified. For the PSTN interconnection regime, we have very clear rules in place, both how negotiations have to go and responsibilities of parties. The FCC has an outstanding proceeding, which has been outstanding for 7 years now, on terms for voice over IP interconnection, and some clarity would be helpful there. For where you should interconnect, again, we have clear guidance both in law and regulation for points of interconnection. Points of interconnection for voice over IP are essentially arbitrary because of the distance and sensitive nature of the economics. Interoperability standards are very clear for the PSTN. There are some interoperability concerns for voice over IP because there are different flavors of SIP being used by different operators, and there's concerns, particularly as we move towards more complex services like SMS and video, getting common standards. Most of the compensation for voice over IP interconnection is being done strictly on a contractual basis, much as the IP level interconnection is done by contract and not by defined rules. And as I emphasized earlier, the traffic that we expect to be exchanged here is not just voice traffic. It's video, it's SMS, it's MMS, and so forth. And finally, PSTN interconnection is largely defined in terms of direct connection, whereas for voice over IP it may well be indirect, using MPLS or other virtual circuits to tunnel through other networks to connect to isolated voice over IP domains, for example. In terms of where we are in the process, within the subgroup, we've reviewed the questions from the FCC and started to develop answers. We've developed a number of diagrams for interconnection scenarios, which are included in the appendix, as I mentioned. We've consulted with a number of experts and are continuing to consult with experts on these issues, and we've developed a draft matrix of considerations for implementing voice over IP, which we're not ready to present in detail as yet. And our next steps are to focus more on the additional applications beyond voice, to get additional feedback on our draft matrix, and to also begin looking at machine-to-machine requirements issues. I think that's kind of where we are.
Thank you. Thanks so much, Marvin. So the last question that we were asked to address, and we're really at an early stage of addressing this one, is about databases, what legacy databases will need to transition to a future all IP environment. And we found this to be a very important question, as we think it might not have been naturally obvious that it was such a key question for us to consider as part of the PSTN transition. And our focus so far has been, first we started to kind of put together an exhaustive review of PSTN-related databases, and we did have that in the appendix. I'm not sure if the appendix got attached to our final set of slides. Same with, I think Marvin mentioned there were some interconnection diagrams. I'm not sure they're in the appendix, but we could distribute them later. But we've kind of just begun to put together this list and to try to think about, how do we want to think about these databases? What would be some of the post PSTN needs that we would want to address? Things like compatibility, interoperability, real-time routing, or other supporting functions, even things like asset tracking. We've started to have debate about some of the market drivers, and this just notes some of the top 4 databases that we have been discussing. Probably most of our discussion has been interesting about things like DNS and its role in the transition. This slide just talks a little bit more about some of our discussion, just how we've discussed how some of the traditional PSTN databases previously deployed may lose their relevance as we move toward towards IP-based communication. An example of that, a maybe obvious one, would be today's toll-free database. Might have less relevance as we move forward. We've talked about how database information may no longer be solely geographically based because of changes in the way people use, say, the way they use phone numbers and what's happened since we've begun to port phone numbers and the changes there. We've talked about how there are many private databases. They may need to report up to some kind of master mediation type database. And we're very early in our thinking on that, and we would love to hear from others on that as well. Similarly, we've discussed concerns over security and confidentiality, that as private databases are shared, how do we maintain confidentiality? So the bottom line is I think this is a very interesting and important question. I think that we're early in looking at it, and we'd welcome discussion and input in this area. So in summary...
Nomi, can I just interrupt one second?
Yes.
There? In the interest of time, can I suggest that this is really what we ought to be discussing in our next session? If we use your summary page here as the guide for our discussion going forward, okay?
That's great.
So thank you.
Sure.
And let's go to Group B and Brian, or Group 1, I'm sorry. Brian and Tom. And Brian.
Pass on the clip.
Okay.
Pass the clicker over, thank you.
Sure.
Where's it going?
To Brian over there.
Might be quick.
Just comment that the appendix slides that I referred to are not in the printed handouts that we have here, but they were in the electronic copies that were distributed to everyone before the meeting.
And they will be posted on the website as well.
Thank you. Thank you, Mr. Chairman. PSTN-B is known as the Successor Infrastructure or Successor Networks Working Group, and I want to emphasize the S on networks because when we look at the evolution of the PSTN, we are not talking about an evolution just to one network. We are talking about multiple IP-based real-time communications networks of the future. When we look at our charter for our working group, we are looking towards these IP-based real-time communications infrastructure and how the PSTN as we know it today will evolve to that. Specifically, we're looking at how to replicate the best characteristics that we have on the circuit switch network today, providing new quality of service and robustness challenges that we face as we move off of today's wireline networks into these IP-based networks. We're focusing on technical characteristics and user experience of the technical networks and identify the challenges and the performance issues that will surround the successor networks. As Nomi mentioned, one of the initial tasks was to look at the questions we had before us in the different focus areas as we evolve the PSTN. And we quickly came to realization, Nomi used the word conflict, I think it was constructive conflict in the fact that when the questions on interconnection and database were analyzed between the two groups, it quickly became evident that we were trying to answer the same questions and going to be coming to the same conclusions. So in order not to replicate those discussions over two separate working groups, we decided it was better just to consolidate those questions into one, and the A team took over those questions, and we relinquished the interconnection and database transition to them. So that left us with numbering, which during the discussions we decided numbering really did not characterize where we're going in the future. Really what we're looking at is user and service and application identifiers. Numbering, sure, that'll be included in there, but as we move to IP-based networks, it's more than just numbers as we move forward. So we renamed the numbering task to user, service, and application identifiers, and we'll be looking at a number of issues surrounding what identifiers look like in the future, how they will interoperate with one another, how databases will need to evolve, and that will factor into the database transition as well. Database transition, same thing. We decided that PSTN-A and PSTN-B were trying to answer the same questions, so we consolidated those. The other two areas were quality of service and robustness and public safety. And specifically in robustness and public safety, we need to look at some of the basic services like being able to call 911 and how that would work as we move into the future networks. As far as our progress, we held a number of conference calls where we discussed the questions that were tasked to the working group, and we made sub-team assignments for each of the working groups. We did have that working meetings with the PSTN-A leaders to clarify and combine the overlapping tasks, and we did hold breakout sessions to address specific sub-team focus areas. The third bullet here, Mike Naraki of Verizon and myself within ADIS, we lead a PSTN focus group, PSTN transition focus group, looking at some of the technological and standards-based implications of the PSTN transition. ADIS has kindly provided the TAC with information that their focus group is looking at. They have 4 specific areas that they've formed sub-teams on, looking at application services, transport, access network, and policy-related areas. And they've come up with a very nice diagram showing the complexities and focus areas that need to be evaluated from both a standards-based and a policy-based aspects as we move forward with the PSTN transition. And it's expected that PSTN-B as well as PSTN-A will continue to work closely with and receive information from the ADIS focus group as we proceed forward with our work. The first sub-team that we formed were on identifiers for users, services, and applications. And Mark Bayless has been kind enough to step up to champion this area. And on the slide, I do want to recognize a number of participants. Again, I won't read their names off, but they're here for reference. Some of the questions we have before us as far as identifiers are what changes might be expected in a numbering plan for optimized IP-based communication services, and what are the obstacles to assigning numbers analogous to how domain names are assigned rather than to service providers, and should number assignment need to retain a geographic component, and how can the receiver of a call validate that the caller is authorized to use the number or other identifier? And what role is enum going to play as a mapping service as the numbering system evolves? Some of the topics for discussion that are being addressed is the recognition that numbers will just be one kind of identifying scheme. We're moving toward a set of identifier directories that will map you to the target, and there will exist multiple mapping databases, and we need some schema for this multiple disparate directories to communicate with one another. It's recognized that geographic-based numbers will continue to be a gating issue as the transition, during the transition, as long as there are devices that use numbers as identifiers. And as we consider the identifiers, we need to consider the linkages between the numbers and PSTN databases. And we also recognize that there's going to be exhaustion sometime after 2042, per the North American Numbering Plan Administrator report of April of 2012. And non-geographic codes assigned for services like machine-to-machine are forecasted to exhaust in 2032. We recognize that there is mapping already in progress today using private enum databases, and there is concerns over Country Code 1, which serves 19 countries, and how all the identifier migration will map in Country Code 1. The next area is quality of service, and David Clark has stepped up to champion this area. And again, I recognize the participants that are listed on the slide. Some of the questions for quality of service are: how will the use of end-to-end IP connectivity impact quality of service? And do we need to define call quality metrics? And how can we measure and assess the differences in QoS and IP service relative to circuit switch service? What entities can perform reliable, unbiased, and comprehensive QoS testing? And can end-to-end QoS be provided across service providers? And how would the use of multimedia impact QoS considerations? Some of the discussions to date have talked about QoS and the fact that QoS and interconnection are interrelated, and many issues impact both groups. So again, PSTN A and B will have to work closely together to tie both interconnect and quality of service together. Voice interconnection between carriers has occurred for several years and is fairly mature in certain segments, such as inter-MSO connection. We should be defining the basics of interconnection, the network-network interface, and at the same time there will be several patterns of interconnection and a lot of issues that have to be sorted out bilaterally or within specific groups. There seem to be a number of questions related to payment and current preference among carriers to build private IP-based networks to carry voice rather than carry the voice over the public internet offering. Additional items for discussion, the need to evaluate performance requirements on IP-based voice, reporting of any performance statistics, and QoS discrepancies as they occur. And since private and over-the-top voice service will interconnect, the question is, will the same performance requirements apply to both sets of services? And to what extent is the performance in QoS of the public internet a matter that should be considered as part of the transition to an IP-based telephone system? The final area of focus is robustness and public safety, and I am championing this sub-team, and the participants, again, are recognized on this slide. Some of the questions being asked are: how will the transition affect network robustness? What will robustness likely improve or degrade in the transition? What technologies can improve network survivability? And for wireless, there are specific questions such as backup power at base station and handsets, and capacity versus footprint trade-offs. And in wireline, we have questions such as backup power for network and home or small business environments, and what, if any, additional capabilities are needed from the underlying broadband network to enable 911 or other emergency services functionality to give us at least the equivalent to that offered by the existing system. The next steps for this group is to review the December 14th workshop material and start addressing some of the specific questions. And the final slide is just, again, recognition of the many participants that we have on the team, and thank them for their contributions to date, and we look forward to their continued contributions. Thank you.
Brian, thank you. Not only is that a tour de force of issues, but you also put us back on schedule. Thank you very much. I would say that for the B team, you get best efforts in timeliness. Dennis, over to you, sir, on receivers and spectrum.
Thank you. Our group, as is typical, has completely redone our slides, so the slides that you see in front of you will be replaced by those that we spent 2 hours this morning redoing.
I did appreciate that at 9 o'clock this morning.
Yeah.
Just after I finished printing 50 copies of everything.
No. I just wanted to indicate that we were consistent. We have done that in each and every TAC meeting, so.
Are the conclusions in the same ladder?
Yeah.
I only left for an hour.
Pardon?
I only left for an hour.
Shouldn't have left at all, obviously. Now let's move forward then into the slides, and seriously, the slides have been mostly enhanced rather than replaced. But if we could move to the slides. Oh.
Yeah, you're getting a little pushback from the guy here who controls the slides. Who says,
okay.
Go for it. You're on.
Okay, you got them. Good. All right, our charter was the receiver and spectrum focus. The modest challenge of resolving receivers, as Dale has pointed out, this is a problem that, to his knowledge, has only been being pursued for the last 50 years, 40 by him personally. So it was a modest challenge for us to take on resolving those over the course of the last 3 months. So to do that, the group is shown here, and as has been remarked upon by the other groups, this has really been a very hard-working group. We have met weekly, with meetings and activities being pursued by different members of this group in between, a tremendous flurry of emails. Actually, it's become my largest single source of emails personally, especially at certain points in the cycle. But a very, very significant effort undertaken by the group. I will highlight that Pierre de Vries, who's not here and not a member of the TAC, was a significant contributor, and certainly Bob Pavlik has been tremendous in pulling a lot of the work together. The work that we pursued was divided into 2 areas. We looked at different spectral areas, as well as looking at receivers themselves and different approaches to the receiver problem. The case studies that we undertook in the spectral areas are highlighted here, and the enhancement on the charts that you'll see on the wall as opposed to the one in front of you is that the areas that we selected were areas where there is opportunity, where people are pursuing them, but specifically are areas that are not currently under a rule-making regime. I will highlight for the enjoyment of the group that we had the beginnings of a significant debate on how you spelled rulemaking. We decided to definitively look this up, and we discovered that, in fact, in 2 different sources, we found 3 different spellings. So we included all 3 for completeness. So apparently this was a major area of debate and continues to be a major area of debate within the FCC, so we felt the need for completeness was very, very important. So moving on. The case studies were really in 4 or 4.5 areas. The first one being the Part A and Part B of digital television. We looked at the channels 2 through 6, and in particular their impact on the subband, the 72 to 76 megahertz band, since there are considerable restrictions on the use of that band based on the fact that it is surrounded by the channels 2 through 6. What we concluded after a rather exhaustive study, going out interrogating the database, looking at all of the places where channels 2 through 6 exist and where all of the allocations are for 72 to 76 megahertz, discovering to our amazement that the primary use of 72 to 76 megahertz is actually maintaining consistency in clocks in schools. Very high profile, high value application. But having looked at that, our large conclusion was that we look forward to what will be done with the spectrum in channels 2 through 6 after it is auctioned and after it's repacked. Because we believe, looking at the database, that it's such a minor area at this point that we really do need to clear that and find an opportunity to use that. Julie aptly pointed out that, and really asked the question, is this counted towards the 500 megahertz or bust? And we all unanimously agreed that it should be counted towards that goal. So that is an interesting finding, and this may be a candidate for unlicensed spectrum, and let the folks that have the exciting ideas of how to use it go at it. The rest of the spectrum, channels 7 through 51, again, it's very difficult to read the enhancements that are here. What you see before you talks to the interference immunity, but the real point is that we need to attack improvements in digital television receivers in order to allow for greater interference immunity as the environment changes. Because the environment really is changing. The various things that are listed here, the TV white space, the opportunity for repacking in digital television and the like, suggests that enhancements in receiver performance in the television range will be very, very valuable and will help us as we move forward to be able to more efficiently and effectively utilize the spectrum. So this is an area for opportunity and for focus. In the 2.4 gigahertz band, the second band that we looked at, there is the broadband radio service, the educational broadband service, and the terrestrial mobile satellite service that are in that area, immediately above it in particular. We need to more carefully look at the 2.4 area to better understand the potential impacts that are there between those services. That has not been investigated to the degree that we feel was appropriate, and in fact there is a goal to move out in that front. We further found that there is a potential opportunity in the 2.4 band, since our understanding of the design is that transmit and receive path are consistent. Therefore, if we put filtering into the path, for transmit, we would enhance receive performance automatically. So this is an opportunity area that we are looking to further investigate. The third band is the 3550, 3650 band. As you remember, or most of you would recall, this is a very famous band that was investigated, and this is the 200-mile exclusion limits around the coast of the United States because of the potential impact based on a study by NTIA. And this was a paper study looking at WiMAX and the radars, particularly the Aegis class ship radars. We found some very, very interesting and useful data in this area in our interactions with our friends in the UK. They have done some real studies using real WiMAX, real radars in this area, and discovered that the interference may be greatly overstated. So this is something for us to dig into, because if the work that was done in the UK is representative not only of the current but future needs of the Department of Defense, those exclusion limits could be radically reduced, even for WiMAX kinds of systems. And that was a very, very useful and interesting finding. The second point, and this has been made actually in the past year with the small cell investigation, the potential of applying small cell in this area to, instead of looking at WiMAX, looking at small cell as the paired incumbent with the sharing of the spectrum with the DoD, that this could work out very well. And we're even more encouraged to pursue that approach and think that that's going to be a very, very valuable approach to move forward on. The final area of spectrum is 2700 to 2900, again referencing work done in the UK. We discovered that there may be, converse of the last band, there may be more challenges in this band than we would have anticipated in the sharing area, more difficulty in dealing with the radars that are in that band than we might have anticipated. So this is an area where further study is needed. NTIA, FCC are now digging into that one, and that's a very, very positive thing. There's also a study that should be issued shortly that would give us more indication of whether there is opportunity here and what constraints might exist on that opportunity in that band. So this is a set of bands that we investigated, but investigated now to be used and applied against the various receiver approaches that we'd use, which will be the next section that we'll proceed on. And I'm not keeping up here. So the receiver enhancement areas that we looked at, looking at the devices themselves, were 4 in number. These are ways in which to enhance the technology in order to cover all of the spectrum of improvements that we're looking for. And we started out with 6 different areas, reduced those to 4, and really 3 of them to look at, the 4th being the status quo, which we think is untenable, but nonetheless we kept it on the list as one of the options to be looked into. The first one is looking at a standards-based approach. For the FCC itself to generate a set of regulations based on standards, industry standards, that would directly address the issue of receivers. We also looked at the standards that are out there in existence today and how those might be applied. Second area was the best practices and the R&D investments that could enhance the receiver performance generically. The third area is an area that's new perhaps to some of you, and this is the interference limits policy approach, and I'll be covering each of these in some greater depth. First approach was, in fact, to look at the standards that are there, and to the bullet that's missing on the chart that's in your hands, to look at the possibilities and the challenges associated with regulatory use of standards. The regulatory use of standards would be a very direct approach to solving the receiver issues, but again, there are many challenges with that, even some related to the FCC's capabilities to apply regulations in this area. There is already on the books the direction that technical standards should be used by the FCC out of the two, the Act and the circular that are listed here. Getting the engagement of all of the parties in even the activity of establishing standards was one of the things that we observed as a huge challenge and at the same time a huge enabler for moving things forward in the standards base. Today, standards seem to be dominantly made by people within a spectral area as opposed to looking to the left or to the right of their allocated spectrum and understanding what their needs are and how to work as good partners in that area. So that is a key area of movement. The thing that I should probably highlight here is that there is consensus amongst everyone that the FCC establishing standards is not the right way to go, but rather adopting standards and deploying might be. The actionable recommendations here, we do need to, first of all, move forward in our own definition and drive in this area. More importantly, there is a need for FCC, NTIA, industrial groups, all of the stakeholders to be organized in a more effective way to ensure that as we pursue standards that we have all of the groups at the table and all of the voices heard. We need to explore the potential for the FCC to provide on a web-based service the standards that are out there to enable and support the use of these standards by other groups. Because today, getting the standards is a very difficult process. Standards are known within each industry group, but are not easily accessible to those outside the group. So this is something that we are continuing to explore, and we are also continuing to examine the root causes of the receiver issues from a technical standpoint as well as public and private policy standpoint and the standard side. So that was the regulatory use of standard side. The next piece is the best design practices, R&D efforts, focus. If we had the ideal technology, we could solve all of these problems just with technology, right? There's no policy required. This is sort of a joke, but if we could have technology that handled any design constraint, it would certainly solve all known problems. Unfortunately, there are limitations, and understanding those limitations and at the same time understanding how those limitations can be circumvented is a key approach that needs to be driven forward. The key enablers are really where our focus are. There are three that we highlight here. Software-defined radio in the back end is really giving an enormous capability that did not exist before. For the classical old-time receiver designers, there was no digital part of a receiver. Receiver was an analog function. If you look at a receiver today, the vast majority of the circuitry, the transistors, are involved in digital design, even to the point of having computational elements, sometimes multiple, in a receiver. That is a huge area that is continuing to grow, and we need to continue to foster it. The drive for low power, low cost, software-defined receivers will enable future proofing of the receiver and will give a great deal of flexibility and functionality. Second area is increasing the ability of the receivers to handle strong signals without being overloaded. This can give great flexibility as well. The final area is really, and again we dramatically reworded it in what's on the screen, the front end part, improvements of the front end are really key. Filters in particular are a big focus. Dynamically tunable filters are listed here, but filters in general. The use of advanced antenna technology is key. Marty Cooper will nod his head knowingly at this point. Dynamic interference cancellation or advanced interference capabilities. There are now operational systems where send and receive occur simultaneously. That capability does not exist in most systems, but in some military systems and in some university systems that exists. That kind of capability can have huge impact in receivers. So all these things need to be stimulated. The actionable recommendation, finding ways to push money into this area, be it through National Science Foundation, through the Department of Defense, or through other means, is a key area of drive. The establishment of the minimum receiver performance in spectrum segments, the understanding of the future of what's needed is also a key area, so that designs can be better undertaken to match the requirements of the environment as it goes forward. Third item is the interference limits policy approach. Again, this is a bit of a new area for many. The notion of this is to not specify the characteristics of the receiver, but rather specify the characteristics of the environment, where the receiver is designed to match the environment itself. It gives great flexibility in how you pursue the design. If you fit within the envelope of the limits that have been established, you are guaranteed that you will be supported. If you exceed those limits, all bets are off. You've designed a receiver that, if it doesn't work, that's a problem for you and those who have purchased your systems. And making that high profile and visible is an advantageous way to go that is attractive to many. There is work from a progress standpoint. We've developed some sample interference limits both for television and 2.4 gigahertz to begin moving down this process. Since it is a newer area, understanding it is really a critical aspect of it. The enabler here is the policies that would incorporate this approach into new rules for new allocation of spectrum. That will allow this to move forward. The actionable items at this point really are to dig in and better understand, both at the 2.4, digging deeper into this, looking at this from a 3550, 3650 standpoint, and also look at UHF so that we can better understand how this might be applied. There's also an approach, a de facto approach, which is something that has been advocated by some within the FCC itself, which is to establish a de facto interference limit, which is sort of a worst-case approach of cellular base station. Presume that it is at that point, unless negotiated by the parties that would be involved, with the FCC serving as the honest third party in these interactions to ensure if there are future things coming down the pike that those are included into the equation. But this would be a manageable way to go at it, where you have sort of a worst case starting out environment where the interference limits are understood, and then move from there to a more pragmatic, probably much more spectrally efficient approach on a case-by-case basis. This would allow for investment by the parties.
Dennis, let's take the next page on
Yep,
the summary, and we'll use that.
That's
just like we did
exactly what I
great.
intended to do.
Those are provocative issues, and I happen to note the chairman making a lot of notes over here. Brian, let's pass the clicker to Brian, so that we can talk about multi-band.
Thanks, Tom. Actually, Brian Markwold, our working group chair, could not make the meeting today, so on his behalf and the working group, I will present our findings so far.
Playing the role of Brian Markwold today is Michael. Go for it.
Wait for the slides to be loaded up.
Waiting for the computer to load them up. Hold on a second. Here we go.
Okay, here we go. Okay, the charter and the working group members. The charter is basically, there are a lot of bands that handset has to include in its design. And, we are trying to understand what are the challenges and can the current implementation scale to support potentially tens of bands that might be allocated in next, upcoming years. And we have industry subject matter experts on various aspects of wireless communications, including all the members of the TAC listed here. I won't go through the names, but also we have recruited a few additional members who has a vast knowledge on these subject matters, including Peter Gao from Qualcomm, as well as William Mueller from Avago, who's sitting behind Dennis Robertson here. So going to the next page, the problem statement basically says 3GPP LTE standards has 33 bands already allocated, 22 FDD, 11 TDD spectrum. And there are more to come. And the handsets are required to support some sort of a GNSS system. It used to be GPS only, but now there are more systems. So every country wants to have their system supported on the handsets. And nevertheless, there's a Wi-Fi, there's a Bluetooth, a NeoFuel. The handsets come with 5, 6 different antennas and 5, 6, 7 different bands already today, and the number is increasing. So how do we deal with this, especially from the policy perspective, as we add more spectrum? How do we make things a little bit easier so that things can be built more efficiently and also cost effectively? And I have to make a note that some of us thinking that we wouldn't be having this problem if we continue to sell the brick phone that Marty built 20 years ago. With all the volume and size, we can fit everything in there, but everybody wanted a slim, thin, very light phone, so we have to jam everything in, and here's the challenge. This is a very high-level snapshot of spectrum chart from 500 megahertz to 4 gigahertz that are allocated for commercial use. Nothing new information here. If you're looking for some hints of upcoming auctions or anything else, these are all public information. Just make it very clear. You can see that on the lower frequencies around 800 megahertz, you will see a lot of allocation. It seems a little bit fragmented per se. You got 700 allocation, 800 megahertz allocations, and as you move up, you have the PCS bands and AWS bands, which is providing most of the voice data capacity in U.S. There are some, BRS 2.5 gigahertz broadband, WiMAX, LTE-like deployments that are coming up. And also there are additional allocations that will be coming up in the next several years per Congress mandates on what to auction from FCC. And there are a couple of bands that we're looking at, as well as industry, as a potential bands to be shared between the commercial use and the federal use. So our working group has broken this handset into 4 subsections. The first section is a baseband. It's basically a very powerful microchip processor that handles all that signaling and basically physical layer to application layer work. And many handsets come with a separate processor to handle these multimedia intensive contents, mostly MPEG-4 type of applications. The next one is called the transceiver IC. So it will take the digital signal from the microprocessor and it will convert it up to the RF signal to be ready to be transmitted over the air. And that transceiver IC has a lot of chips that usually it's CMOS based, and they'll try to just consolidate as much and as many components into a single chip as possible to remove all the burdens and complexities for the design of the handset. Third block is what we call the discrete RF front end. I think Danielson just talked about how we need to focus on this front end to enhance the receiver performance. So these are the components that cannot really fit into a transceiver chipset because of many various reasons. There could be some temperature drift requirement. There's some operational requirements. There's a power requirement. Like PA has to handle a higher power than the LNAs and so forth. And then there are filters including duplexers, some of the switchers and diplexers, things in nature that will make sure that your transmit signal is not bleeding into your neighbor signals, and also make sure the received signals are not harming other operations within your phone. And this portion will basically connect the transceivers with antenna. And obviously you need some sort of antenna to be effectively transmitting any signal over the air. So in our working group, I think the consensus is that first 2 blocks, there hasn't been enough technical advancements occurring at a faster pace than later 2. So our focus will be on discrete RF front ends and the antennas. At least that has been the discussion and agreements within the working group. So this is a bit of an eye chart, but wanted to show the complexity of a handset design today. So this is a high-level block diagram of GSM/LTE handset for a North American carrier. On the top, on the top left-hand corner, you will see a GSM chipset or module. It's a quad-band supporting 800, 900, 1800, 1900 GSM. So it pretty much covers the global GSM deployment. And on top of it, you have additional bands, including your PCS, AWS, cellular band, and whatnot, to offer the LTE implementations as well as HSPA. So you already see that this phone has already, a 7, 8 bands that's supporting. And it's got 2 antennas, one for the primary transmit, the other one for the receive diversity. And most of the data system will require second antenna to enhance the performance. And I wanted to show another example of diagram, which, in addition to what you've seen before, it's adding a CDMA capability. And in this case, there is a requirement to have a voice data simultaneous transmission. So they ended up adding a third antenna for the CDMA voice. So it adds additional complexity, and there's a cost and insertion losses and whatnot. So things are getting complicated as we move forward. And imagine adding 2, 3, 4 additional frequency bands into the phone design. And some of these component vendors are already to the limits of what technology can provide at this point. It might be worthwhile to note that because of simultaneous transmission in 2 different frequency bands, there are some intermodulation interference to internal handset that people will have to, in this case, they put a notch filter to notch out some of the undesired signals. And also, they happen to be very close to public safety frequencies, so they have to put a special filter to make sure that out-of-band emission is sufficiently rejected per FCC requirements. So they are doing an extra step that what some of the frequency bands might get away without the additional filters and so forth. The next slide is it's a proposal from the vendor community on how to build a future handsets, future meaning within next 12 to 24 months. And in this diagram, what it's indicating is that because of a lot of focus, discussion, interest on carrier aggregation on LTE, meaning you combine 2 disjointed spectrum and offer higher bandwidth so that you can utilize spectrum more efficiently. The cost is device gets more complicated. And as we talked about on the previous case, because you're transmitting or receiving at different frequencies at the same time, there are additional interference concerns that people have. So either you have to use a components that has higher linearity, adding more cost, potentially consuming more current. Also, there are additional components be able to switch different modes of operation. In this case, the proposal is put all the lower frequency operation into one side and all the higher frequencies on the other side, and you throw some switches, diplexers, and be able to operate without causing interference. And the drawback is I think there's a slight increase in insertion loss and maybe additional performance degradation you have to overcome somehow. And I think that's a still ongoing discussion / debate amongst the industry, the licensees and manufacturers and component builders and so forth. So we have learned a lot as we were discussing with the industry leaders in this field. And this slide is kind of a pictorial representation of a future frequency agile. I mean, we have a lot of different names for it. We call it cognitive radio, software defined radios and whatnot. But basically, we want to have something that has more intelligence. It's more tunable on the RF front end so that you don't have to have all the complexities. With a simple software, you can control which band it can transmit or receive, and then don't have to deal with all the trade-offs and things that we have talked about. Among the discussions that at least we had in our working group, there seems to be 2 bookends of arguments. I think if you listen to existing manufacturers of RF front ends, they're dealing with a state-of-the-art technology, and they don't really see how you can replace these discrete RF front-end components as of today. There are very significantly high amount of rejection you have to give per FCC rules, and it varies from frequency band to frequency bands. But as we move forward, there seems to be a more stringent requirements on how much rejection you have to offer, both on transmit side and receive side. The other bookend is people who are more coming from baseband and some of the transceiver chipsets. The software radio or cognitive radio is almost there. The Moore's law of doubling certain capacity every 2 years or 18 months has really helped the innovation in this area. And there are some of the commercial chipsets that are coming into the marketplace for the commercial use on the handsets. They are somewhat tunable, but they are not, they cannot really do a magic to replace all of the components that we have. So the other camp will say, well, there will be some transition innovation coming, and it will happen one step at a time. They'll have to eat the elephant one spoon at a time. So we have a good debate going on, and hopefully we will have a good balanced view of the industry that what might look like in 5-10 years down the road. So I think that's the biggest challenge for us to how do we balance the perspectives of both sides of the story, and how do we factor that into some of our policy makings as we are allocating more spectrum. So for the future investigation, obviously there's antenna. Today you saw these antennas. It's very tiny single antenna. They're covering from 700, 800 megahertz to 2.5 gigs. So it covers over 2 gigahertz. And as we talk about incentive auctions, the antenna range has to go for another 200 megahertz. So that's 10% increase. And I think the vendors seem to have some concerns about performance degradations. So hopefully we'll have a better understanding of some of the challenges. Tunable elements, we talked about tunable filters, tunable switches and whatnot. There are a lot of good discussions we're having. We hope to bring additional industry experts on this field and have a good debate and advise us as we go. And also there's a power amplifiers that can be tunable, or they can just do a very gigabit 80 analog to digital converter that can just transfer all of the digital signal to the RF signal with power amplification gain included. So there's some work going on trying to get some understanding of that. So there are a lot of other interesting topics, discussions that we're going. So what do we do with all this information? So the policy consideration is that I think we're trying to break it up into 3 different parts. Within next 2 to 3 years, there are some immediate spectrum allocations like AWS-4 that will be coming to the market. We want to be aware of technical availability so that we don't overshoot or undershoot in terms of our requirements, and we understand what are the possibilities that can happen. Also, there's a midterm where some of the bands per the Congress mandate, there will be some auctions coming on the table. We like to understand whether some of these discussions we're having on tunable filters and soft-defined radio can be actually implemented, and what benefit would that have on licensees as well as manufacturers and consumers and so forth. And then we also like to see, in a longer term, how would things scale? How would things evolve moving forward so that we have a good input to how to maximize the spectrum utilization from the regulatory perspective? So with that, I think we have a lot of a good discussion, a lot of fun discussions actually with all the members of TAC, and I think we will be glad to take some questions later on.
Great. That's great, Michael. I mean, that's no small set of issues that you've identified there. Okay. Kevin Sparks, let's move on and talk about security and privacy.
Okay, if you can load the slides, and if someone can pass the clicker down. Our group is a new topic area for the TAC, and slowly progressing its way down the. All right, thank you.
Hang on, we're fixing it at this end too, Kevin. You ought to see what you just missed here is Walter punching the screen of his laptop and trying to figure out why it won't respond.
Yeah, everything's going touchscreen. We won't even know how to use a keyboard before long.
I'm doing it again. It's actually easier when you touch it.
There you go. Okay, take it away, Kevin.
All right. I'm going to report out on the wireless security and privacy work group. This is it's a new topic area for the TAC, and so a new group assembled. I'll just note, I'll go through some of these first slides very quickly and get into the more the meat of the discussion. Just note that we, since the formation, we did recruit another member to the TAC, Ellie Karala from Ericsson Research. And I'd like to thank all the members of the group that have been actively engaging in the topic and pulling in subject matter experts from their respective companies to help bring the whole team up to a sort of a common level of understanding of the security and privacy vulnerabilities that exist in I'll call it the wireless ecosystem. The charter, if you will, of the group is kind of summarized here as examining security and privacy vulnerabilities, assessing how they're currently being addressed by the industry and by users, and then to recommend finally what kinds of mitigations and countermeasures there could be, and what constructive roles could the FCC play in pushing those kind of mitigations forward. The next couple of slides are the questions, which I won't go through except to say that we kind of grouped them into a few categories to break down the work of the group. So some of the questions that kind of are the overall summary questions: security pertaining to cellular, pertaining to Wi-Fi. There is the network operations aspect, questions about how networks are being operated today for detecting security failures and events and taking action upon those. Network integrity, meaning attacks specifically on the network, either the commercial aspects or bringing the network down itself. Privacy aspects as distinct from security, and then finally a set of questions related to the assessing what the level of impact of each one of these vulnerability areas would be. So we sort of have the pleasure of working on an area that's both very deep technically, but also has many different aspects to it if you look at it on an end-to-end basis. So it's kind of broad and deep at the same time. If I skip forward a couple of slides here, the current status of the group is, as a new group, we've spent most of the last time since the last meeting kind of preparing summaries of the vulnerabilities and possible mitigations in each one of these areas, and relying on our members to bring subject matter experts to broadly inform the group. We're kind of at the stage where we're mostly complete, but not quite complete, with that initial scoping activity, and then we'll be going into deeper dives and working the topics in parallel, particularly trying to come up with creative and impactful and constructive mitigations for these things. And a lot of people work on security and wireless security, but what we're trying to do is kind of take a top-down approach and try and Pareto out what the most important vulnerabilities are, focus attention on those, and then focus our effort going forward in the next phase on what would be some of the best approaches for mitigating those. Let me back up one. So the next couple of slides where I'll spend most of the discussion kind of break things into four areas. The first one has to do, and our kind of initial charter here was security of wireless air interfaces, with the option of broadening it. And we felt any discussion of security of the wireless security needed to look at the whole ecosystem of wireless, because some of the biggest vulnerabilities occur outside the network itself. So starting with cellular technology, we recognize that cellular technology varies quite widely in its level of security. In general, cellular is not, we kind of think of this as the image of a chain, and the security of any system is only as strong as the weakest link. And the cellular network part of this is by far not the weakest link, but it does have vulnerabilities. And the older generations of wireless technology have the greatest, maybe not unexpectedly, vulnerabilities. So if you look at 2G cellular technologies in particular, very weak encryption has been broken for quite some time. There are more advanced forms, but of encryption, but those have generally not been adopted for economic reasons. One-way authentication, which is rather limited compared to newer cellular generations. It is possible to procure 2G GSM fake base stations for about $5,000. That's kind of a low barrier of entry, and with fake base station you can gather up all kinds of information from unsuspecting users. Another area, though, is very important because you can say over time, as the generations move on, that will sort of take care of the security problems. But a more insidious form of vulnerability that we found is that of most of the devices that we have are multi-generational, for good reason. You want to be able to use them on any network, but it opens up the possibility of what's termed a bid-down attack, which is essentially that you either, because you've roamed into an area that only has 2G coverage, or your device has actually been compromised, and it's forcing the device to request 2G, that you kind of drop down to the lowest common denominator of security. So I'm going to spend more time on the vulnerabilities here than the potential mitigations, because I would say we're in the very early stages of the mitigation part of this. So I've put down some of the initial thoughts, and many of them are in the area of education and best practices and things like that. But I'll try and highlight the areas that go sort of beyond that. But there may be some simple things here of giving users better control over their use of data on 2G, for instance, which is of limited value in the first place, but could be of negative value if it opens up security threats on the device. Another area in cellular that has come up in our discussions as an area of concern is the kind of the insecurity of SMS. And particularly if SMS is adopted for like SMS to 911 type scenarios where attacks on essentially emergency networks could be propagated from a low security SMS type messaging system. If I move to the second area of Wi-Fi, this is in the Pareto of threat areas. Certainly Wi-Fi is very different from cellular. It's a bit more a Wild West environment. But Wi-Fi is not created equal. There are many kinds of Wi-Fi. There's managed Wi-Fi networks, all the way down to mom and pop coffee stores, coffee shops, and so what is possible to do in managed networks, and I think there's a lot there, may not be possible in the sort of the great lower end of the spectrum here. But there are a lot of threats out there from people employing, automated sniffing mechanisms, hijacking sessions, particularly if you're not good about logging off when you leave a session, and even things like similar to fake base stations having hotspots which emulate other legitimate hotspots, and essentially suck up credentials and present fake web pages to steal security credentials. These are certainly all threat areas. There are best practices here that can be employed. Certainly enterprises utilize VPN technologies to a great extent. Consumers generally do not. But there should be opportunities for the same type of protections that enterprise take to be extended to consumers and for operators of the networks that the devices are primarily attached to take advantage of offering services in those kind of spaces. If I guess I was on the previous line. Sorry, going the wrong way. In the third area, this of all the four areas, the third area relating to devices and applications and the usage of those devices, this is the area of the largest of vulnerabilities and perhaps the most pervasive and difficult ones to address given the nature of the environment. In a way, this area is sort of the perfect storm of opportunity and risk of valuable assets being stolen. Given the extensive use that we all use of mobile devices, oftentimes mixed usage, so for both business and personal use, there's a lot of business and personal confidential information stored on mobile devices. It makes it a very attractive target. Couple that with an environment where an applications environment, for instance, which is sort of very open and diverse, many different players, and no one owns things end to end. And there are also supplemental parts of the device environment, such as removable storage devices and Bluetooth interfaces that expose more vulnerabilities. Jailbreaking devices tend to allow apps to access the root of the operating systems and get access to a lot more things than they would in a non-jailbroken phone. And we should also highlight, even though it's not part of the mobile itself, the server side of these applications store a lot of data, and there have been some very high-profile losses of confidential data on the server side of things. So that could even be the highest risk area of all in here. And then finally, the last area, it's titled network, but here it's specifically attacks against the network itself as opposed to the users of the network. There's plenty of malware out there that is increasing all the time. Denial of service attacks against networks, signaling denial of service, SMS attacks can bring down networks, and also subsets of the network, which would be, for instance, being used for emergency services. So now, in the chain of things, certainly networks in this country, large networks take great effort and precaution to try and stay ahead of the arms race in this space. That's a real challenge, but it's certainly a lot of effort applied there. So we wouldn't highlight that this is the most concerning area, but all the areas of the security chain need to be rigorously pursued. And there was another aspect towards the network. It's not an attack directly against the network, but against the economic opportunity of the network, and that is if users come to feel that the devices are inherently, or their device environment experience is inherently insecure, you can reduce the opportunities for mobile commerce, machine-to-machine applications, and the like. So the work, the next steps for the group are to dive a lot deeper into the mitigations and countermeasures. We've tapped a lot from our member companies, but we want to tap a lot of other external sources, expert sources in this area, and hopefully by September we'll have a much clearer view of the most promising and impactful mitigation strategies.
Kevin, thank you. This is a huge issue that reaches far beyond even this agency, as you know, and the work that you and your group are doing is crucial. The chairman has just leaned over and whispered in my ear that he has been so captivated and interested that he's blown off some other stuff on his schedule and is going to be staying with us for the discussion. And I assured him that it is the first rule of TAC that we end promptly at 4 o'clock. So don't feel any pressure, Shahid.
Thanks, Tom. All right. So
it's on its way.
Excellent.
But it's got a long way to go around the loop.
Here, we can click by hand. We can
click by hand. That's fine. All right. Well, first, I just want to say thank you to everybody in our wireless apps and M2M working group. It's a new group, particularly Walter, who's been instrumental in helping us drive thank you, the content for this particular working group. All right. I'm going to try to skip through these very quickly, but I just want to quickly say that M2M is an incredibly broad space. Some people even call it Internet of Things. It touches practically everything we do in our daily lives, from getting in the car to turning on your thermostat to going to the hospital. So it really touches pretty much everything we do, and that's one of the challenges we had, how to narrow down its scope. So given that, our objective, if you scroll down to points 6 and 7, were really to recommend some practical and tangible actions on behalf of the FCC to the broader industry in terms of how we break down some of the barriers related to regulations and other standards. And I'll walk you through some of those issues that we learned over the course of the last few months. The other objective we had was to facilitate conversation between various different verticals that leverage M2M technologies. And again, we talked to a number of different companies in the broader ecosystem, and a lot of people had a lot of things to say. So I'll walk you through those in the next couple of slides. Just moving on to the next slide, please. Yeah. All right. I just skipped through a couple of intermediate slides, but the last 3-4 months we spent interviewing approximately 30 different companies that play a very major and key role within the M2M ecosystem. They range from obviously the carriers. We spoke to Sprint, Verizon, AT&T, but we also spoke to utilities, as well as companies as diverse as Nest, a small home automation company made up of a bunch of people from Apple, and I believe Apple is even selling that product in its stores. Each one of them offered a very different and distinct definition for M2M. And the other thing I would say, they all had very different requirements as far as interoperability is concerned, or even things like security, privacy, who hangs on to the data that belongs to the customers, and so on. So we compiled everybody's data points and their perspectives and insights, and what I'll do today is walk you through some of the key headlines. So if we can actually move to the initial observations. There you go. All right. So these are some of the challenges and inhibitors that we heard from some of the companies we talked to. And again, we spoke to about 15 companies over the last 3-4 months. We had about 30, and to be honest, we just didn't have enough bandwidth to speak to everybody. But we haven't left everyone out yet, and we still plan to speak to most of them. Let me just kind of give you some of the headlines. One, first and foremost, we heard M2M is a very low-cost, low-yield business. So they want the cost for M2M transactions to be very minimal. We're talking sub 1 cent type pricing. So that's something we heard unanimously from almost everybody. The other thing we heard is they want the 2G legacy network to be around. And now I know, Kevin, you talked about how 2G is so insecure, and we also heard, PSTN being transitioned. Now, what do we do with 2G? Almost everybody we spoke to.
I just want to make one comment. Before some people pass out, I just want to make clear, we're presenting perspectives of the companies we talk to. These are not necessarily recommendations we're making, but it's important to understand what their perspective is.
Right.
So I just want to make clear, these are the perspectives of the people we talk to.
That's right. Thank you for pointing that out, Walter. Yeah. And
Brian going for his chest.
There goes tomorrow's
headline.
headline.
Not only do they want PSTN to be around, but they want 2G to be around.
Some of the people you talk to said.
That's correct. Right. That's right.
By the way, some of these devices are dialing in.
That's right.
That's correct. That is absolutely correct.
And they're rotary.
Correct. Just some of the other things we heard was, look, we're proprietary protocols obviously stymie innovation, but they're also needed in some instances. So there's a requirement for those in the marketplace. Utilities, they were very vocal about, look, we need our own private networks, we need spectrum. We have a requirement of low latency, mission critical solutions. And if there is a public network out there that can do that, we're open to leveraging it. Just moving on, data ownership was a big deal. Who owns the data at the end? When you look at mobile health, when you look at transportation, whether it's telematics or automotive, a lot of the companies we spoke to highlighted, well, who actually owns the data at the end? And that's something that we'll have to kind of look into and really figure out how we manage that going forward. Just moving on to the next slide. Catalysts for growth. One of the questions we asked them, well, what do you think are the catalysts to really blow up this M2M market that we have here today? And as many of you know, you can pick up a chart from IDC, Gartner, Accenture, and other places. They all have a very exponential curve related to M2M transaction, not only from a subscriber unit perspective, but also a revenue perspective. But the growth, almost unanimously, the companies we spoke to said, look, we need to keep the regulations to a minimum. And they really spoke about the regulations associated with the verticals they work in. So whether it's utilities, whether it's healthcare, whether it's transportation, each one of them were heralded with some specific standards and regulations. And they like to see those either harmonized or at least streamlined so that they could start building solutions for those particular verticals. One idea that came forward was this notion of safe network, where companies could literally plug and play their devices and be able to interoperate without having to do a lot of certification, which increases the cost. The other issue that we heard was around the idea of IPv4 and IPv6 addresses, how to manage them going forward. And I know Charlotte talked about that in your working group, but that was one area where they said if everything went IPv6, things would be really easy to work with. I think I'm going to stop here. There's a whole list of summary items and observation. I think the key learning that came out of all of the interviews was the notion of safe network, 2G sunset, how to handle that, how to properly manage that, because a lot of things are hanging off that network, and just taking it offline would really disrupt the the growth trajectory that everyone's contemplating. They're also talking about the excluding M2M from the USF tax construct.
Not a tax, but talking about fee structures proportional to the revenues they're getting.
That's right. Thank you. Thanks again, Walter. That's right. We have Walter in all of these interviews. I appreciate that.
Great clarification.
Thank you.
I manage heart attacks.
You're the aspirin. And lastly, I think a lot of the folks we spoke to said, look, FCC should really reach out to others around the world to see how others are managing these machine-to-machine transactions. And so it's really good to see, Chairman, you speaking with other countries, because I think that was one of the key themes among all the interviews we conducted. Look outside what's happening in the other countries and other regions.
So, Shahid, thank you very much. I mean, that's a significant exercise to reach out and begin to try and scope something that is kind of like the folks feeling the elephant. Depends on what you're feeling as to how you define it, and that's a big. What you're doing is very helpful. Nomi, let's go back to you and the A-team and your summary, then go to Brian, and in 57 minutes we need to try and address the summary issues that you identified, as well as quickly move through some of the others so that we can hit our guaranteed 4 o'clock ending. So.
I actually think Russ is going to take the summary, right?
Okay, we're throwing it down to Russ. So, okay.
I'm happy to, yeah.
Okay, so summary, back to some of the issues we covered. Copper will continue to play a role during and after the transition to the PSTN. One of the call-outs there was all copper is not created equal, as we covered. Interconnection, there's many options and methodologies from a tech standpoint. There was also a great deal of input from Brian's presentation, which we'll be picking up moving forward. The real question comes down to what needs to be connected in the future in terms of applications, as well as maybe interconnection of different applications, if that's something we should be addressing as the TAC. And that's the next bullet there, is that should that be our focus in terms of the application interconnection. Databases, there's many databases in existence. We're going to focus on identifying the needs to incorporate and backwards compatibility needs. And again, taking a look and working with the other working groups like Shahid on the M2M to look at what the requirements might be in that area as well. So we've begun some discussions around future broadband access and the ability to support competition. There's another call out that some of the group members may want to bring up at this point as well. And looking forward to advice from the FCC and fellow TAC members in terms of the next 3 months before the September readout.
Okay, are there any points that various members of the committee want to make on any of these 5 bullets?
So,
Adam.
Just one. Sometimes when you look at these databases, you look at the business side, there is very much an operational side. So when you look at things that exist like common language, CLI codes, things of that sort, they actually do end up being important in how you reconstitute networks when you have problems. Okay? And so just besides identity, I would say the important thing is operationally, how do we maintain a nationwide communication system and keep it viable? And the databases play a significant role in that. So when you look at a service company having to reconstitute its service, and it brings in workers from other regions, other companies to help out, the databases actually play a significant role in how that work is done, right, and how quickly you can actually reconstitute everything. Right. Okay? So I would say that's something that's important to pay attention to.
Okay, Tom has just used the officially recognized TAC means of seeking recognition. Tom.
Thanks, Tom. I think two sort of transcendental issues that cut across Group A's work and Group B's work, and that I think we'll have to work hard on sorting out, is the difference between the old network world where the services were provided by the physical network operators and the new network world where we have over-the-top service providers as well as physical providers. And so we say, oh, gee, we'll have to move forward with regulation. Well, not so fast, because there's this whole bunch of entities that we don't have any very good way to regulate, even if we wanted to. That sort of regulation may not be on the table. They don't have to be in the United States. We're not China. We're not going to cut them off. And so it's a different world that doesn't have a one-to-one mapping. We could decide, and maybe this is something we should debate, that regulation is regulation of physical networks. After all, they have a better chance of being a monopoly and a choke point than an over-the-top virtual network. And that's okay. We were discussing this morning CALIA, and you say, well, okay, if you can always intercept on the physical network, then at least you have some entry point, even if you can't control the virtual networks. But I just mean that as an example. So we have to look at what could we regulate and what can't we regulate, and how is the world still going to go on. Second thing is, of course, that the world has passed by some of the discussions that we're having, and that our tendency coming from the old world to say it'd be awful if there was a communication island and there were people who couldn't be reached from outside. Well, there is one. It's called Skype. Not only one, but it happens to be the biggest one. And so, except in the small case where somebody has a Skype-in phone number, they're not really reachable on Skype from outside Skype, and the world hasn't ended. And so we're going to live in a universe where there are some islands and where there are some not islands, and we want to. And so I think when we look at issues like that, we can't be absolute and say that there can't be any islands. There are, and people
require a common default, though.
Well, so I think so. Then you have to say, for those who don't want to be on an island, right, have we made sure that there's a way to not be on an island? But even then, I think, and learning from email, our tendency is to think, well, we used to have these huge databases like the 800 database, the LERG database, this hierarchy of databases. That isn't going to happen either. Instead, more like the world of email, that domains, and I'm using domain generically, but domains will be discoverable, but how information, including directories, is managed inside domains is probably outside of our control. And so all that we can make sure, just as we do with email, is that you can go to some far server and say, I want to connect to a user who tells me that his identification, whatever, or her identification, whatever that is, on your service is this. And that's all the outside inquiry is going to know. It's not going to have any idea how the authentication, how the verification, and how the actual connection is made. So I think we have to come to terms in both groups that we just don't have the same tools for solving problems that we had before. That may mean that we can be much more creative, but it also means we have to be much less prescriptive. And so we're going to have to deal with those limits in our work going forward.
Okay. Tony.
Tom made a point, and I appreciate Tom offering, different potential points of views and not necessarily his own. But you said something in there that I just feel is important to point out, given that.
Which Tom are you upset with?
Never you, Tom. Never you. So no, seriously, I'm not upset at any Tom yet. But the point of regulating only the subset that we have a means to regulate is as dangerous attack as you can, excuse the pun, that we can take here, because it is those infrastructure builders that we might have the physical plant, the physical entities that we feel we can regulate are the ones that are investing to take us from the PSTN to the new, and that approach will do more to negate everything we're talking about in this TAC of how do we push and continue the leadership position we're in. So I just felt it was important to make that point, I understand there's no easy answer to the fact that our environment is changing and there's so many different providers, but I think, we have to level the playing field, in my opinion, as opposed to pick and choose who we can regulate and who we can't in this environment. Otherwise, we're going to have behaviors that we don't want in the industry, in my opinion.
Yeah, and if I can just have a second, I did mean to tee that up rather than answer it, but it's a very interesting, and Tony's taken it one step further. Since there are entities that we can't regulate, if the consequence of creating an absolutely even playing field is we regulate no one. And so I'm not even going to go near answering that, but that's a big question for us to be looking at, and the implications of it.
Yeah, and Russ.
I think that what came to mind when you were talking, Tom, to me was the terminology public switch telephone network, which we have today. And what you were describing to me is sort of a parallel network, almost a private network. That the question becomes, when does a private network or a parallel network become sort of the norm? And at least in my mind. And I think as a TAC or the FCC, there should be encouragement to interconnect these different types of networks and services. The question comes down to what is mandatory, what is regulatory, and I think there's some real issues there because a lot of these services are originated outside the U.S. You don't have to be in the U.S. to provide VoIP. So it comes outside the jurisdiction to some degree, So there's this, need for, I think, a global or international, how do we encourage this interconnection to take place? And I think it's still evolving.
Joe?
I just wanted to actually amplify the point that we actually have on our summary slide, and it sort of builds on Tony's comment about how do we think about leveling the playing field from a regulatory perspective. I think it also, to think about innovation and job creation and how we sort of get the machine moving even faster than it is. Everybody uses everybody else's components in solutions. So we just have to make sure there's a vibrant market so that those that need the components, and I could even see it in the M2M discussion, is we have to rely on everybody else's components to make solutions for customers and accelerate innovation. So to me that means some level of a vibrant wholesale market for components that don't make sense to be replicated in a private environment.
You see, Mr. Chairman, there are never any simple issues at TAC. But I know you've never heard any of these arguments before. Jesse.
Yeah, thanks, Tom. I guess my issue, and it goes back to Tom's point, I think a lot of the innovation and the requirements for these sort of over-the-top or vertical private networks that may lay on top of some base network, that's where a lot of the innovation is going to take place, and there's a lot of specialized requirements. Let me just pick security as one. I mean, whether you're talking about M2M types of networks that are designed to protect mission-critical things like medical networks and so forth, those networks need to have some assurance that where they do the interconnection, because they will have to do interconnection, that's regulated to a point where they know that the information that's moving from, say, private network A over some base network to private network B is protected. So I think this whole issue of security, as we talk about what you regulate and what you don't regulate, is an important area that we ought to look at. And I don't think we can just treat that lightly, as we want the innovation to happen, but I think we've got to understand it in the context of privacy and security.
Okay. Any other PSTN A discussion points? Let's go to PSTN B. Brian, your summary sheet.
Actually, I don't have a summary
Your son's
sheet.
summary.
I have 2 sheets. If you go to the identifiers, topics of discussion, Walter. No, it's like the fourth slide down.
I mean, that's some good example.
Fifth or sixth. Next one, I think. So looking at the summary, on the identifiers, certainly one of the areas is recognition again that the identifiers are more than just numbers in the future, and we have to look at how we can move toward a set of identifiers that's going to map you to the target where you want to deliver the call or information. And because of that, there's going to exist multiple databases within the network in order to support that, and we need some sort of schema to address that. And geographic-based numbers will continue to be a gating issue during this transition because there will continue to be devices out there that use numbers as identifiers, and those need to interwork with devices that use other forms of identifiers. And certainly the other area of concern is the resource exhaustion, which the North American Number Plan Administrator reports 2042. And then M2M services even earlier, 2032. The second area, of course, is the quality of service, and 2 slides forward has those topics. And again, this relates to some of the interconnection and security issues I think that Jesse raised when we talk about evolution to the networks of the future. Certainly the interconnection between carriers, which has occurred for voice services and is fairly mature, such as inter-MSO connection, that needs to be looked at and how it impacts the future evolution of the PSTN, and focus on defining the network interfaces. And again, as Jesse mentioned, when you go between private networks, some underlying transport back to a private in, say, a machine-to-machine environment, those network-to-network interfaces do become important. The questions related to payment seem to keep rising up when we talk about quality of service, and there is a current preference to build private IP-based networks rather than to carry voice over the public internet. And there's many reasons for that, including maintaining quality of service as you transition, the security issues, and so forth. Let me ask Tom or any other members of the PSTNB if you have any other thoughts you'd like to inject.
Yeah. Again, on the numbering specifically, that's very closely tied, of course, to the database work that Group A is doing. And I think what we're beginning to realize is that, first of all, numbers have really disappeared. They're only identifiers anyway. That is, those numbers used to make little wheels turn inside of switches, and they really meant something. And they don't anymore. They're just a text string that gets looked up in the LERG. I think a little bit different from Brian. I think we'll have numbers as long as we have devices which are only capable of accepting numbers as input for addressing. They're not inextricably tied to the geography. And as a matter of fact, I have no idea where you are when I dial your cell phone number these days. You might have moved or you might have just roamed. And so I think that the transition away from numbers is actually happening fairly quickly. That the geographic link is breaking, and that probably we should work towards making a specific recommendation, perhaps that numbers be encapsulated in a domain. That is, I would claim that my phone number is now .pstn, just like any other identifier, and then that we can work our way towards the transition by encapsulating the whole numbering scheme as just one of a number of multiple domains, and then we don't have to hurry away from it because
it might fit inside another.
Which might fit inside another, but the domains tends to be a flat world of domains, at least if we learn from the email example. But still, there is this big, and enum is actually a step in that direction anyway. But I think this is a problem that's pretty solvable if we encapsulate it. And since it is, and since it's a gating problem for moving to the future, I'd suggest that Group A and B ought to work on pretty hard and try to bring in very concrete recommendations this year.
Okay, David. Adam, who was waving down here? Okay, in this order. Go ahead.
I wanted to elaborate on a couple of the comments about quality of service. In these privately managed networks that we're talking about, the networks that are being used for VoIP over IP today, the technical mechanisms that are available for quality of service are reasonably good in terms of allowing you to have the quality of experience that you need. And as those providers are interconnecting, I think they're doing a pretty good job in the sort of bilateral, multilateral industry context of getting the quality of service they need. The issues of quality of service and whether it's a matter of concern to the FCC really depends on the kind of interconnection you're looking at, and that's why there's a very strong linkage here between a discussion of quality of service and a discussion of interconnection. There will be people who provide voice as an over-the-top service like Vonage. There will be people who choose to use their public internet technology and carve out capacity for voice in that context and sell it as a service by the carrier. And all of these things are going to need to interconnect. And clearly we don't have end-to-end quality of service in the public internet today. So one of the questions, which I think is perhaps not a technical question, but it's a question that we should bring at least to the FCC's attention, is to what extent should the FCC be concerned that all of these modes of delivering voice have equal opportunity to achieve competitive quality of service. And, it could very well be that if voice over the public internet is the poor stepchild, that has a consequence that we should take into account. So I've been trying to focus the quality of service discussion in the context of an interconnection discussion, but I think it really comes back to the question of, in the public internet today, where we do see voice being carried, but we do not have specific tools for quality of service available end-to-end, only available within individual ISPs, is this a matter which is of concern? And I raise it now as a question, but I think it's one we'd like to try to find the foundation to.
That's a great thing for this group to be chewing on. Absolutely. Right. Okay, Adam.
Yeah, so I'd like to actually address something on the identity issue, okay, and numbering, and really look at something very forward-leaning. Okay? Because having identity, having the services, and having the apps poses, I think, a modern question, which you didn't find in the PSTN, and that is, what's the composability of what you have created? What services can I string together? What apps can I string together? And therefore, the underlying databases really have to be much richer, okay, and in some way safe for me to discover what can talk to what, okay, under what circumstances, who gets paid for it, okay, and make all of that kind of information, in fact, transparent and usable, because this is what drives innovation. Now, there's a very neat book written by Steve Johnson from the New York Times, Where Do Good Ideas Come From? He said, from old things where you find new combinations, essentially. So I think there's something really profound in this topic. Okay?
Yes.
Mine's quick. And something that Tom said earlier. I really like the idea of the DNS infrastructure as something that could actually become a place for where we hold identifiers in the future. And I really don't like the idea of trying to find something else, because I think we actually have something that works and is at scale, and probably at greater scale than any of us even imagine today. Yet there are huge issues. There's security issues. There's probably a scale issue or two in front of us. But rather than, I think it's an area for us to focus and ask, is it appropriate? Could we make it work? Because it is ubiquitous today.
I was just going to make the same point. It would be repetitive about the DNS. Well, I'll just make one quick point. There's a lot going on in the infrastructure. Wow, this is in stereo. There's a lot going on in DNS below just all the top-level domain stuff we read about in the press that is around optimizing the use of DNS for other purposes. So all I would say is I would suggest to the groups A and 1 that it would be worth a little bit of time to take a look at what's happening in the DNS environment. There really is some novel work going on beyond just domain identification.
Charlotte, David, Adam.
Just really quick. I think when we talk about voice, voice is like the past application. If you look at our children don't really do the voice thing. They do the data thing. They do the texting thing. And so when we talk about quality of service, I think we have to also think about what is the quality of service we want to provide for all applications, regardless of, what it is, whether it's voice, data, video, et cetera.
I just want to pile on for a second. I was in China last week we'll go into a restaurant. There are 4 young women sitting on a couch. One is talking on her phone, and the other 3 are thumbing. And I said, excuse me, that answers everything. David.
Well, first off, I'm thrilled to see so much fine work going on in these 2 groups. I won't try to figure out what their names are at this point. I am just sort of a little concerned about what maybe we're not looking at, and I want to check. Maybe it's deliberately out of charter because the Commission's already dealing with it internally, or maybe it's something that we should be looking at. And I'm thinking of all this through the prism again, and we sort of talked about this at the beginning of the meeting. What are the things that we can do to accelerate the innovation and in this case, accelerate the transition and make sure it goes smoothly? So 2 areas that seem to me perhaps are not being covered, and maybe they are stranded users, and particularly I'm not necessarily talking about rural versus urban so much as usage patterns. Have we covered the case of the elevators, the alarms, and all that stuff? And if that's getting covered internally by the Commission, that's great. But I just want to make sure that is a potential bottleneck, I think, to some of the transition if we don't get it covered. Another that may fall in that category is do we feel like collectively we've got a good handle on all the existing regulations and arrangements that are going to become either obsolete or perhaps financially unsustainable, and what the time frame is, so we know what has to be done by when, so that essentially our regulatory and environment and business arrangements don't end up slowing us down.
Isn't that that last one? That's kind of the inverse, however, of what we're saying. If we come up with a schema, ergo, something else goes away. Is that a fair assumption?
I'm just wanting to make sure that we've. I think that's a fair assumption for some of these things. I'm just wanting to make sure somebody's working backwards from the punch list.
Okay.
And has the punch list of all the things that, I'm worried that at some point we start finding that things are becoming unsustainable, and simply because we just didn't anticipate something we could have dealt with.
We are now a half an hour from turning into pumpkins, and I don't want to, but Greg, and then we'll go back to Nomi.
Let me make this very quick because David brought this to the fore. That a few weeks ago I was speaking at the National Fire Protection Association on this topic, and the biggest concern there is that they have about 40 million fire alarms and security alarms connected through telephones, PSTN right now, and they don't work very well through VoIP, because that was the biggest complaint that I heard. Now, you may say 40 million, that's a good way to spur the economy, but like David said, you have to leave enough time and enough budgeting time to do all that.
Okay. Nomi?
It's just a quick comment. I guess I just wanted to acknowledge David's first point. I really like both of your points. It is on slide 3 or whatever. It just where we do agree with you that many services will still require copper for quite some time, and the transition will take a while. And then at the same time, I think that there are some very good investments happening in the copper space. I think I even saw like a Frontier analyst report today that talked about how they're able to get 40 megabits per second over copper, and so there are interesting investments happening where copper still is effective as a broadband means, and so I think that will help some of those alarm security circuits, elevator phones, gate phones, ringtone circuits. I agree that was going to take a long time. Good point.
At the risk of stepping off the dock here, let me see if I can, in real time, pull together this discussion of both groups. Are we talking about, we're really asking about how to operate when everything is OTT? And that means, and that there are 3 pillars to that kind of an environment. One is the identifiers and database schema that has been talked about, because eventually everything becomes a DIP for everything. Secondly is the application, the interconnection of applications, or the ability of applications to move across multiple networks. And thirdly is, I guess, related to that, which is IP access across competitive networks, which includes copper and includes stranded users and issues like that. But if we take that broad umbrella, are we really talking about those three legs of the stool? Great. Okay. Then let's move on to Charlotte.
The only thing I'd say, though, is that your number one said OTT.
Yeah.
And I don't think it's just restricted to OTT. So OTT means to me that it's a person that doesn't have any physical facilities.
Got it. Cool.
Right?
I'm with you. Yeah, exactly.
But I think, Tom, just to add that, maybe mentioned in the third bullet, that it would be easy, in a way, much easier if we only had to deal with the world completely post-transition.
Right.
But probably part of the hardest issues are when we're halfway there.
That's what I was trying to guess.
And done.
Right. Yep. Okay, Dennis.
Yep. You can bring up the summary conclusions, the next step slide. As per the earlier comment, this is radically different than what you have in your hands, but we'll put the focus there. I'm really going to jump, in the interest of time, going to jump very quickly into the next steps focus for this, and use this as a point for moving forward. The first of these is this continued focus on the potential opportunities for impacting in the spectral areas. So maybe those that would like to talk to the comments around the DTP, the 2.4, the 3650 through 3550 through 3650, and the 27 through 2900 band spectral discussion that we had, this would be the time to talk about that, and then we'll move through the points. Hearing no interest in talking about that, we'll continue. The next point is to determine how to better project future spectrum plans so the industry can be better prepared. While we complain about receivers not being adequately focused around the changing environment that they find themselves in, we don't provide much information in that area either. So that's a key focus for us. Coupling that with the next one is this process for integrating receiver performance factors and the interests of all parties. And all parties here are certainly the industry itself that is focused on the use of the spectrum, but it's also the adjacent spectrum owners currently in place and those that might be in place in the future, with the FCC involved to help with that future side. So those two couple tightly together.
So are there discussions for what Dennis has laid out the next steps here? Do we have any? Yeah, David.
I'm going to be real consistent today. I'm going to just keep coming back to that acceleration point. So I just want to encourage this group over the next period to see, try to identify which of the things we could do near term, we could encourage the commissioner, the government to do, or the industry to do to speed things up. I think this is really exciting space you're in. And so, what specific things can we do to speed things up? I'm not looking for an instant answer, but if in the next few months we could get really focused on that, it would be wonderful.
Yeah, that is clearly the focus of the group, to identify those things that we can take action on right away. Some of those were identified in the earlier part of the talk.
Yeah, Mr. Johnson. Dennis, one of the issues I think that I see is that it's not how you're going to do it, it's how you're going to start doing it in terms of transition to a new area. I think the last year we've seen a lot of discussion between people, companies, arguing going forward to a new regime in terms of looking at receiver performance or staying with the status quo. You're going to be looking at any opportunities or any suggestions for what are the getting started steps? I mean, the problem I see with going to any of the proposals you have is how do you start within an industry group and get movement towards a new approach to doing things, given the risk, uncertainty, and other factors always associated with that?
Yeah, and again, some of those were identified. That's where we attacked the bans, the suggested bans. So the television DTV area is clearly one of the areas, and fortunately we have representative from the National Association of Broadcasters and the Consumer Electronics Association in the group, so we're able to really double click on that area. The 2.4, we're already starting work digging into that area here in the FCC, working with NTIA and the other bands. So that's where, in exactly the context, that's our way of getting at the initial targets.
It would be really great at the end of the process if we could take even a small step towards changing the current context.
Yes. No, we're looking to no small steps. We only take big steps.
Like all right. Okay, let's move on to Michael.
Well, actually, Mr. Chairman.
I'm sorry, Dennis.
Yeah, I did want to add just a couple more the new items because they are quite important.
Got it.
The item we didn't cover yet is this adjacent cellular band notion, and I didn't really give the context. This is in the interference limits. This is moving the interference limits into a specific context. The interference limits idea has been around for a little while. It's a really exciting idea in this context of moving rapidly, to David's point and to the point here where we want to take a big step, not a small step, looking at what we can do in the interference limits area by using cellular base station as a stalking horse initial starting point is a key one. And then how we would move off that base. But that will be a key one for us. The other two items that are on the charts but not in your handout are to, and this is one that I had to get to, Tom, for you, and I'll read this, provide actionable recommendations to the TAC on the effective approach for receiver standards, interference limits, and their interaction and integration. And that really is a punchline that was missing, and your smile is very appropriate.
I love it. Thank you. We love the term actionable.
Yes. And the final item is to analyze the role of enforcement and incentives, because we didn't really hit that as we should have until this morning when we recognized that omission. But there is going to be a role of enforcement in this. To make it work, you have to have enforcement. Hopefully we can have incentives that will limit the role of enforcement, but we need to have that balance point built in, and that's an area that we will be working on.
So you will be coming back to the group with specific ideas to discuss.
Yes, absolutely.
Okay. Any other discussion? Okay. Michael, on yours, can we kind of focus on page 10 and your breakout of future investigation? Is that the right place to go? And the question becomes, if folks can turn to that in the section on multiband. It's up on the screen now. There it is. Are there things, Michael, are we pointing to the right
I think so.
thing? Okay, and are there things that people want to add to this? Are you up or down, Walter?
I'm down.
You're down. Are there things people want to add? And Marty, I was looking straight at you, buddy, you know.
But there are two impressions that are becoming evident right now. First of all, Walter, I don't know if you can find about 2 slides earlier, one of these block diagrams, the amount of technology that is stuffed into these cell phones that you've got in front of you right now is just incredible.
Mind-boggling.
And when we first did our block diagrams, we couldn't fit all the stuff onto one slide. They were so complex. As an example, in this thing, they show an antenna, but your cell phone's got 7 different antennas in it. It's got 7 different systems in it. You know, well, I'm not going to go into all those details. What's the takeaway? The FCC can be very aggressive in what they ask the industry to do, because whatever you ask for, I guarantee you they're going to come up with it. I don't know if that makes sense to you, but we have only just started. The second conclusion that I draw from this is if you look at the future of what is happening to cell phone designs, we're getting within our sites the possibility of building a cell phone that's totally software configurable. And when that happens, it's possible to reach for any channels that exist for any specific user. And when you combine that with, you knew I was going to say smart antennas, you now can get not only wide frequency coverage, but geographic coverage. And when you achieve that, and it's going to take 10 years, all of the work that you're doing in spectrum allocation is going to be irrelevant. There's going to be so much spectrum that we're not going to know what to do with it all. So we're very encouraged.
Well, there is already a Cooper's Law, as we all know, so we can't say that what you just said is Cooper's Law, so I'm going to say that it is Cooper's corollary, okay? It's Cooper's corollary to the if you build it, they will come philosophy, which is you're saying to the chairman, if you mandate it, it will get built.
As usual, you got to the essence.
There you go. Okay. Greg, are you? Yeah.
I think Marty's looking way into the future, and I'm looking a little closer. And that one of the things you haven't asked for in one of your requirements is if you were to ask for spectrum allocation that has something to do with harmonics, like if your multiband radio could talk on the first and the third harmonic, then it's a lot easier to build it. And that might get rid of some of the stumbling blocks that you mentioned that are in the way of building these things.
Okay, let's go to Kevin and security. You've got somebody's. Did I miss? Oh, I'm sorry.
I was just going to make a point that I think one of the things that was not mentioned in the slide deck is the importance of being able to support TDD operation. It's going to become increasingly difficult to get additional paired spectrum. Certainly the stuff that we're seeing from PCAST in terms of being able to do spectrum sharing is a lot easier if you can only deal with one band. And how you integrate TDD processing into the multi-band radio design going forward is, I think, going to be important. If we don't look at this, we're not going to be able to use vast swaths of spectrum.
Don't worry about it. Cooper's Law is going to take care of that.
Well, much of
by magic.
A lot of the new spectrum that is going to be able to be made available is not going to be paired.
Pairing
and
issues.
So if we don't adequately handle TDD, it's not going to be.
How do you resolve in devices spectrum pairing issues? Is what you're saying, right, Milo?
Well, just saying that there will be devices that are FDD only, and there are devices today that are TDD only. All Wi-Fi is TDD. How we integrate increasing amounts of TDD in CMRS-style operations, I think, is going to be an interesting challenge.
Milo, we agree with you, and we're going to look at that.
Okay. But by the way, I was remiss at the outset in not welcoming Greg and Milo as new members of.
I was here last
time.
time.
The group.
Yeah, he was here last time.
I was really remiss in forgetting the fact that Greg and Milo were here. I remember it well. You had on this great tie, as I recall. Anyway, Marvin, go ahead.
One of the technologies that was mentioned is spectrum aggregation, where you use two non-contiguous segments of spectrum as over one virtual wideband. And this is going to have significant implications for the way you do band allocation going forward, because instead of struggling to have large contiguous channels to allocate at auction, you can allocate smaller channels, which may make for more competitive auctions, and rely on the technology to enable operators to combine channels to achieve virtual wideband behavior. And exactly what the trade-offs are between contiguous and non-contiguous channels needs to be looked at, of course, but I think this is going to change the way you think about spectrum allocation.
Okay, let's go on to Kevin and security. You had, looking here, if we go to your next steps page, you said scoping, deeper dive analysis, and overlapping topics.
Right, and yeah, I didn't really mention the last one, but obviously machine-to-machine security is an important area, and it's a direct overlap between two of the groups. So one of the things we want to spend more time on is coordinating the findings from the machine-to-machine group and trying to factor that into the vulnerabilities that we are addressing in the security group. I did actually make it through the presentation, although there are a couple of points maybe that I'll make that I didn't get in before, and that is, as I'd mentioned, the devices and usage areas being kind of the least tractable or most challenging of areas. And one of the observations that one of our members made, I think it's a good one, is that in a way the usefulness and the productivity of this device application environment and the use of the data being shared between the applications and this ever increasing value and productivity we get out of that whole ecosystem, has the flip side that the more productive and useful it is, in a way, the harder it is to secure, because there is a lot of data being transferred between applications built by a lot of different people, some of which, in the garage. And so, in a way, it's akin to having moved from TDM networks to IP networks, and all IP networks present new challenges of reachability and things. So, certainly one of the areas that we're going to be spending a lot of time, racking our brains over is what kind of creative solutions can you come up with to try and make that environment more secure. And a couple of the items I don't think I mentioned before was there's work on trusted execution environments. A global platform is one of those that we'll look more closely at, and whether those are practical and cost effective in mobile devices. And another possibility in the range of application trust certification. Not a regulated thing, but on a voluntary basis, if there were almost a good housekeeping seal of approval type, third-party independent certifiers of applications, that could at least give consumers choices. Okay. And so there are a couple of the mitigations that I hadn't brought out before.
Jack?
Just a quick comment. When you were speaking before, I as an operator, I kind of heard maybe the whole denial of service thing maybe not being as big an issue as an operator myself. I feel like it is. I think if you ask the operators around the room, that you'd hear a profound, we spend so much resource internally dealing with this every minute of the day that it's becoming a bigger and bigger issue on the public network, and something that I think it's broader than wireless. But when I heard it, I heard a little bit, maybe not as much.
Absolutely, and that certainly came out in our discussions on the operator topic as well. I guess what we were kind of looking at from the perspective of where some of the biggest vulnerabilities are and what is sort of currently being done. And we know certainly in North America, the large operators are putting tremendous effort into that front. So, but we're open to any suggestions for things particularly things that would be actionable towards the FCC, that could make it easier for the operators to, give them more tools or weapons, if you will, in that battle, for sure.
Okay, Peter, Dennis, Tom, Charlotte. Marvin, are you up or is that residual? Okay. Peter.
So I'll make it very quick. So I think there's a canary in the mine, which is the Defense Department has mandated a hardened version of Android, because what's happened is so many of our service people around the world now are using, obviously, smartphones, not just for their missions, but also to Skype back to their families, to send email, whatever we all use our phones for. And I actually believe, Mr. Chairman, that there is a new role for the FCC related to security, and it's much like Marty said about antennas. I think that if the FCC mandated certain basic hygiene requirements about security in the civilian infrastructure, the reality of it is all of the sort of various participants in the ecosystem would be forced and could conform to that. I think that, if the role of government, one of the primary roles of government is to protect its citizens, there's a lot of frustration right now in the private sector that the government has sort of ceded that role when it comes to security and sort of said to the private sector, look, you guys figure it out. It's not really our mandate. And I would challenge the FCC to maybe think about a new role related to security and defining these
So
kinds
let me
of
put
requirements.
that on the back burner because I've had the benefit of having the chairman whisper in my ear for the last few minutes. Dennis.
Yeah, I'd like to propose that look at another dimension to this. You've talked in what you've done so far about the devices, the networks, and so on. But the other dimension is who's doing the work here. And it really does divide into a variety of areas. We tend to think about the hackers being in a university. I think about the kids down the hall and so on.
The ones you're training.
Which I'm training in my classes.
In order to
they're outstanding,
okay.
and I could give good. No,
where'd they get their
anyway?
skills?
But it goes beyond that. Even in the hacker community, we have the emergence of organized hackers, not just individual students doing something for a lark. We have the criminal element, again, individual criminals and organized crime. Though we'd like it not to be there in the corporate world, there are both individuals that are trying to get their job done, and gee, if I could just extract that, I could get my job done easier, and organized agencies that do this. And finally, there's the state-sponsored element to this. But I think it's somewhat key to look at this as another dimension of the problem. Who's doing the...
Yes.
Yes.
Yes. I mean, spot on. It's a triangle. Brian, Tom, Charlotte.
Thank you. Just to go back to Peter's comment with regard to security and the applications, I think one of the things we do need to realize is security is a broad area, and we aren't just talking about networks and infrastructure. When you talk about devices and applications and operating systems, it really opens up. And you mentioned, our Department of Defense, soldiers overseas using it to Skype back or whatever. And then you're also talking about foreign networks that are involved, and just want to make sure it was clear that the issue is quite broader than I think characterizing it as a network issue.
Oh yeah, totally clear. I was just making the point that I think that the Android hardening project is a canary in the mine that the FCC could pay attention to that covers that entire spectrum from network to application. That's all.
Okay, Tom.
Yeah. Two suggestions for the group, and they may not want to take it because they have plenty of work. I've been involved with the smart grid rollout in Vermont, so it's a big M-to-M application. And two problems that we've run into. One I think is legitimate and the other not, but they both need to be addressed. When it's government, as in the municipal utility that I'm on the board of, that's rolling it out, and all this data is being collected, and there's also open access laws for government data, you suddenly find that everybody, it's literally a public record how much electricity somebody consumes every 15 minutes, which has various interesting uses in divorce court, marijuana prosecutions. So there's a privacy. The privacy issue is very real, and we may have to look at the distinctions between right to know and protecting these mountains of data when it's government that's collecting them for a legitimate purpose. But the second issue, and I urge everyone not to ignore it, is the Luddite fear of the radio signals. And the state legislature mandated opt-out for smart meters. We have a cluster of opt-outs in our town around the local nursery school because the nursery school convinced everyone that if they had a smart meter in their house, they'd be destroying.
And the commission has just begun a new inquiry into that issue. Yeah.
And so that I don't know if that's too much of a stretch for the group, but it is liable to be a gating issue in some applications.
So Charlotte put her tent down while you were talking. I don't know whether it was a reaction to divorce or marijuana. I wasn't sure as to.
Neither. I just figured we had 5 more minutes. So.
Okay. Anybody else? Okay. Shahed, don't feel any pressure.
Thank you. As always. Let me just walk you through the next steps. I think it's clear that I do need to work with the PSTN, both the groups, as well as the wireless security groups. I think we have some coordination to do here. You brought up smart grid and smart metering. We spoke to a couple of utilities, some of the largest ones in the U.S., and both of them did highlight those specific issues and suggested, who owns the data, right? Privacy issues as well as security issues. So we have a lot of work in front of us related to those. But our goal is to complete our interviewing process and then really kind of distill the data we have uncovered through these interviews, and then really get down to some very actionable items related to the challenges and issues that we have uncovered from these companies, and kind of start focusing on what those challenges are and how we can help to mitigate those. That's sort of the plan going forward.
Is there any other thoughts? Clearly, what Shahid is leading is the kind of the ultimate work in progress of all of us, because it's a business yet being defined. Peter, are you up for this, or has Peter walked out?
He's not even here.
Peter just wanted to be called on so we would all notice he'd left. Okay, Mark. Charlotte, go ahead.
This is a fascinating area, not only because of its size, and we've talked to companies like General Electric that think that this will be even larger than the current use of mobile 10 years from now, but because of its implication on licenses. So we've gone from a world that's exclusive use licenses primarily by vendor, and unlicensed.
Yeah.
And here, and I applaud the FCC for the medical band network that they put in place on May 24th, which is a vendor-neutral license. How this is going to all evolve is going to be extremely interesting and will require probably different license models and may turn the whole licensing scheme on its head. I don't know if this group has the time to even explore experimental licenses or new ideas and licenses, but I think that whether it's this group or whether it's a follow-on to this group, I think that's an important point that's going to have to come out.
So you're really suggesting because M2M, therefore what?
Therefore what? And it's an opportunity for new license models that could really spur innovation.
So you can factor that in, but of course he's got to define it first. Okay, we're going to go to Charlotte and then give.
Just really quick, I think that we talked to a lot of companies on the IPv6, relative to machine-to-machine transactions. So I'd like to give you the information that we have from them.
That'd be
great.
So you can actually use. That's great, Charlotte.
There's a power company that has 2 million devices. That they already have in place in California, with another 1 million or so in Australia. That is kind of very interesting with some of the challenges that they're dealing with. So
Walt, you get the last.
Yeah, I just wanted to support Mark's view. In the interviews we've had to date, it's clear that the decisions the companies are making in terms of what type of wireless strategy is at least influenced by the licensing regime that underlies it.
Yes.
They're looking at the effect of the licensing regime, but you'll see they'll go to unlicensed because it frees them from certain types of regulation. It gives them they can do non-standard work in other areas where they need wider scope. So we're already seeing that the license drives the application at least in an indirect sense, and it's a very important influence on that front.
Okay, there is the clock on the wall says 4 o'clock. I'm reminded of a story of when Jess Unruh was the Speaker of the California Legislature, California House, and they had a constitutional deadline to have finished business by a certain date, and they hadn't, and he looked up and he says, the chair recognizes that it is now midnight, and the chair orders the clock to stop. And we have a chair sitting here who can do whatever he wants with his clock. So, Mr. Chairman.
Well, just a few brief comments. One, thank you again to Tom, to the working group leaders, to all the people who've been participating in this. Many of you traveled from out of town to be here today. Very much appreciated. And when you think about it, I was thinking about the reports and the discussion today, all of which is being streamed online. When we think about international comparisons, this doesn't happen anywhere else in the world. A group of this
level of knowledge, background, experience coming together to discuss and make real progress on the issues that we've focused on today. This is really unique, and I hope you all take a level of pride in being associated with that. I actually think it's this kind of thing that will continue to drive the American innovation machine going forward. And so I think you're participating in something that's very important for that reason. Relevance. I want to take a second to assure you that everything that we've talked about today, everything that you're working on, scores very high on the relevance meter for the work of the FCC. What you are all doing is not only consistent with our agenda, it's helping shape our agenda, not just for this near-term period, but for a long time. And I want you all to know that as you continue the next round of work, which I think we can all see from the topics today, is extremely important. A couple of people have said this. I just want to echo this as strongly as I can. These areas are so important. The opportunities so immense. Some of the risks that we've talked about today so serious that I want to ask you as directly as I can to really focus on actionable recommendations in these areas in the context of the next meeting time frame, which is September 24th, I think. There's no waiting around on any of these issues. On the wireless security issue that we got a very good report on today, it was a really interesting report because the vulnerabilities column is very serious and very real, and I think we all understand that it was just excellent work in compiling and kind of doing a taxonomy around the vulnerabilities. We have a lot of work to do on the solutions. And so that's an area where, in particular, I wanted to ask that working group and TAC overall to accelerate your work. It's extremely important, and we could use your help. I say that not at the expense of any of the other issues that were raised today. I think we could have. They're all A's and 1s, as far as I'm concerned. So thank you very much. I'm looking forward to seeing you all on September 24th. I will participate again, and I'd like to both hear actionable recommendations, see a robust discussion, and but I also don't want to set that as I set that as the outside target. And I would ask some of the working groups and Tom to consider whether there are things that can happen between now and September 24th, so that September 24th is not only a recommendations meeting, but where we can report on some things that have actually happened. So the staff that's all here, Henning was one of the people I didn't mention before. There are others. All the staff here are ready to work with you, immediately between now and September 24th, both to make progress on actionable recommendations, but also to get some stuff done, because this is just an incredibly important set of topics that you're raising for us. So thank you very much, and I'll see you on the 24th.
Mr. Chairman, thank you. 3 hours of your schedule to sit here and listen to us talk about is no small investment or no small indication of your commitment. We understand your demand for action. We feel the imperative. We will deliver. Thank you, sir. Thank you, everybody.
Thanks, everyone.